There was a time when the deepest parts of the ocean were imagined as empty places, not empty in the peaceful sense, but empty as in erased, scrubbed clean by darkness and pressure, untouched by motion or breath. When people first tried to picture what lay beneath the furthest reaches of the sea, they often imagined a silent void, a place so hostile that life simply gave up and turned back long before reaching the bottom. It wasn't a cruel assumption. It was a logical one, shaped by what life on land seemed to require: light, warmth, air, a gentle range of conditions where fragile bodies could persist without being crushed, frozen, or dissolved. The deeper the ocean went, the more those familiar supports disappeared. Sunlight thinned, then vanished, temperatures dropped, pressure increased beyond anything a human body could endure. And so, for centuries, the conclusion felt obvious: nothing could live there. Early explorers spoke of the deep sea the way people once spoke of outer space: vast, unreachable, and fundamentally incompatible with life. Nets lowered into deeper waters came back nearly empty. Instruments failed. Cameras couldn't withstand the descent. Every attempt to peer further down seemed to confirm the same quiet belief. The abyss was a biological dead end, and perhaps beneath those conclusions, there was something comforting about imagining the deep as lifeless. A boundary, a limit, a reassurance that life had edges, and beyond those edges was only stillness. After all, humans have always found comfort in knowing where things end. But the ocean has never been particularly interested in human comfort. As technology slowly improved, as curiosity pushed a little further each decade, small cracks began to appear in that long-held certainty. Creatures were discovered at depths once thought impossible: strange forms, unfamiliar shapes, organisms that didn't fit neatly into existing categories. At first, they were dismissed as anomalies, drifters from shallower waters, misplaced by currents or chance. Surely they hadn't evolved there. Surely they couldn't belong. Yet the deeper scientists looked, the harder it became to maintain the illusion. Why? People began to wonder quietly. Would life stop so neatly at a certain depth? Why would evolution, which seems endlessly inventive, simply surrender to pressure and darkness without a fight? Nature, after all, has a long history of thriving where it shouldn't. On frozen peaks, in acidic springs, in deserts where water appears only briefly and rarely. Why would the deep ocean be any different? Still, the idea lingered. The abyss felt different, more absolute. The pressure alone seemed final, thousands of times greater than what we experience at the surface. Enough to collapse metal, to shatter bone, to crush anything with even the smallest pocket of air. Surely life could not adapt to that. Surely this was where possibility ended. And yet, curiosity has a way of softening certainty. When deeper submersibles were finally built, machines designed not to conquer the abyss but to survive it, something unexpected happened. The ocean floor was not barren. It was quiet, yes, sparse, but not empty. There were traces of movement, signs of habitation, evidence that something was living, enduring, persisting in a place long thought sterile. This realization didn't arrive with drama or fanfare. It came slowly, almost reluctantly, as data accumulated and assumptions fell away. Each discovery nudged the question further: if life existed here, what else might be possible? And how wrong had we been about the limits of survival? It's interesting to notice how often humans mistake unfamiliar silence for absence. The deep ocean does not announce itself. It does not rush or shimmer. Its life moves slowly, conserving energy, blending into darkness. To a hurried glance, it looks empty. To a patient one, it reveals something else entirely. The belief in a lifeless abyss was never really about evidence. It was about imagination, or rather, the lack of it. We projected our own vulnerabilities onto the planet, and assumed that what would destroy us must destroy everything else as well. But life does not share our preferences. It does not require comfort. It requires only possibility. As those early assumptions began to crumble, something more subtle shifted too. The abyss transformed from a dead zone into a frontier, not in the sense of conquest, but of humility. A reminder that Earth still holds places where our understanding is shallow, even when the waters are deep. And perhaps there is something quietly humbling in that. The idea that beneath miles of water, beneath pressure that would end us instantly, life continues without spectacle or attention. It doesn't need us to witness it. It doesn't need to resemble us. It simply exists, following rules written by chemistry, time, and adaptation, rather than by human expectation. One might pause here, letting that thought settle gently. If the deepest, darkest places on Earth are not empty, then what does that say about life itself, about resilience, about the stories we tell ourselves when faced with environments we do not yet understand? The illusion of a lifeless abyss wasn't shattered all at once. It dissolved slowly, like a myth losing its edges, and in its place emerged something far more intriguing than emptiness, a quiet, persistent presence, waiting patiently for us to notice. As we drift deeper into this idea, it becomes less about correcting an old mistake and more about opening a door that leads downward into water that grows darker and heavier, into a realm that challenges our instincts about where life belongs. And without realizing it, we begin to follow that door, not with urgency, but with calm curiosity, letting the surface world fade gently above us as the descent begins. As the surface slowly recedes from thought, the ocean begins to change its character. The water grows denser, darker. Waves and weather become distant memories, replaced by a steady, enveloping calm. This is where the idea of the abyss stops being abstract and starts becoming a place, one with shape, depth, and presence. Far out in the western Pacific, beyond busy shipping routes and tropical islands, the seafloor opens into something extraordinary. The Mariana Trench is not simply a deep spot on a map. It is a long, curved scar in Earth's crust, stretching for nearly 2,500 kilometers, deeper than Mount Everest is tall. If the tallest mountain on land were placed inside it, its peak would still lie hidden beneath more than a mile of water. It's easy to imagine trenches as narrow cracks, but this one is vast. Sloping walls descend gradually at first, then steepen, drawing everything downward into an immense underwater canyon. The descent is slow, almost imperceptible at the beginning. Water pressure increases quietly. Light dims without ceremony. Nothing announces that you are crossing a threshold. Yet, everything is changing. What makes the Mariana Trench especially fascinating is not just how deep it is, but that it exists at all. It formed where one massive tectonic plate slides beneath another, sinking slowly into the mantle below. Over millions of years, this process carved a trench so deep that it effectively separates surface oceans from an entirely different world beneath them. A vertical journey through it is less like swimming downward and more like traveling through layers of reality. As one descends, familiar reference points dissolve. There are no horizons, no seasons, no weather. Time itself feels altered. The water temperature stabilizes, hovering just above freezing. Sound travels differently. Even gravity feels subtly changed by the immense mass of water pressing from above. This is not an extension of the surface ocean. It is its own environment entirely. And yet, despite how alien it feels, this place is still part of Earth's living system. It breathes in its own way. It circulates nutrients, hosts organisms, and participates in cycles that stretch from the highest clouds to the deepest rock. The trench is not separate from life. It is woven into it. At around 1,000 meters down, sunlight becomes a memory rather than a presence. Blues fade first, then greens, until the world is painted entirely in darkness. Below this point, vision loses its importance. Above, life dances with light. Below, it learns to live without it. Descending further, pressure builds relentlessly. For every 10 meters, another atmosphere presses inward. At the surface, our bodies experience one atmosphere of pressure. Here, there are hundreds, then thousands. Metal creaks, materials compress, anything fragile is reshaped or erased. And still, the trench continues downward. What's striking is how quiet it all is. The deep ocean does not roar. It does not rush. It settles. Movements are slow, deliberate, restrained by the cost of energy in a place where resources are scarce. This quiet is not emptiness. It is efficiency. As the descent continues, the walls of the trench rise around you like submerged cliffs. Sediments slide slowly downward, carrying with them tiny fragments of the surface world. Mineral dust, microscopic shells, organic debris. Gravity never stops working here. Everything eventually drifts down. The Mariana Trench feels less like a destination and more like a process. You don't arrive so much as become immersed. The deeper you go, the less the rules of the surface apply. The ocean becomes heavier, thicker, more absolute, and yet nothing about it feels hostile in the way we might expect. It feels indifferent, patient, as though it has been waiting far longer than humans have been asking questions. At these depths, the idea of the trench as merely a geological feature begins to feel incomplete. It is not just a fold in the planet's crust. It is an environment shaped by extremes, yes, but also by balance. Everything that exists here does so because it fits, precisely and elegantly, into the constraints imposed upon it. And perhaps that is the quiet lesson of entering the abyss. Extremes do not eliminate life, they refine it. They narrow possibilities until only what truly works remains. The trench is not chaotic. It is selective. One might wonder, drifting here in thought, what it means for a place like this to be alive. Does life require abundance? Does it require light, warmth, motion? Or can it exist in near stillness, sustained by patience and chemistry, evolving slowly over timescales that dwarf human history? The Mariana Trench invites these questions without demanding answers. It simply exists, vast and deep, holding within it conditions that challenge nearly everything we assume about habitability. It reminds us that our perspective is shaped by where we stand or float. What seems impossible from above may be perfectly ordinary below. As we move deeper still, the trench narrows toward its deepest point, a place where the ocean floor reaches farther from the sky than anywhere else on Earth. This is not a symbolic depth, it is a physical one, a place where the planet folds inward and presses life to its limits. And yet, even now, the story unfolding beneath us is not about absence, quiet, subtle, enduring. The trench is not waiting to be conquered or explained away. It is waiting to be understood, slowly, gently, on its own terms. The descent continues, unhurried. The surface world feels impossibly far away now, like a dream that belonged to someone else. Here, in the growing weight of the ocean, the idea of Earth as a living planet takes on a new meaning. Life is not confined to the places we find comfortable. It follows opportunity wherever it appears, even into the deepest abyss. And as the pressure continues to rise, as darkness becomes complete and absolute, we drift closer to a place that marks the very edge of known life on Earth, where the ocean reaches its deepest breath and holds it. At the deepest point of the Mariana Trench, the descent finally eases into something like a floor, not a flat plain, but a vast shadowed basin shaped by gravity and time. This place has a name, Challenger Deep, But names feel almost inadequate here, as if language itself becomes thinner under so much water. Challenger Deep is the lowest known point on Earth's surface. More than 10 kilometers beneath the waves, it lies farther from sunlight than any other place on the planet. If distance alone defined isolation, this would be one of the most isolated environments imaginable. And yet, it is not cut off. It is connected to the rest of Earth through slow currents, falling particles, and invisible chemical exchanges that never truly stop. For a long time, this place was thought to be the absolute end of life. Not just unlikely, but impossible. The pressure here is staggering, over 1,000 times the pressure at sea level. Temperatures hover just above freezing. Darkness is complete, not the kind your eyes can adjust to, but the kind that has never known light at all. It seemed reasonable to assume that this was where biology finally met its limit, but Challenger Deep quietly refused that narrative. When the first instruments reached this depth, they didn't immediately reveal dramatic scenes or bustling ecosystems. Instead, they showed something subtler, almost disappointing at first glance. A seafloor covered in fine sediment, a stillness so complete it felt timeless. And then, slowly, unmistakably, life. Not abundant life, not colorful reefs or swaying forests, but living organisms, present and active, existing at a depth where life was never supposed to persist. Tiny creatures moving across the sediment, microbes embedded in the mud, traces of biological activity where none were expected. It was a moment that quietly redefined the boundary of the biosphere. The biosphere is often imagined as a thin skin on Earth's surface, wrapping land and shallow seas where sunlight fuels growth. Challenger Deep challenges that image. It reveals the biosphere as something deeper, thicker, more resilient than previously believed. Life does not merely cling to the surface. It extends downward, following chemistry and opportunity into the planet's most extreme spaces. One might pause here and wonder what it means for life to exist at a boundary like this. Is Challenger Deep the end, or just the deepest place we've managed to look so far? Does life truly stop here, or does it simply become harder for us to detect? The organisms found at these depths are not visitors. They are not lost drifters from above. They are residents, adapted, specialized, and shaped by conditions that would destroy most other forms of life instantly. Their very presence tells a story of long-term survival, of generations evolving under pressure so constant that it becomes invisible to them. At this depth, the concept of bottom feels misleading. Challenger Deep is not the end of a vertical journey, so much as a turning point in understanding. It marks the lowest confirmed reach of complex life, but it also opens questions rather than closing them. If life can exist here, then the limits we imagined were never limits at all, just temporary gaps in knowledge. The seafloor at Challenger Deep is often described as moon-like, but even that comparison falls short. The moon is dry, exposed, bombarded by radiation. Challenger Deep is wrapped in water, shielded from cosmic noise, shaped instead by slow geological forces and constant pressure. It is alien in its own way, but also deeply earthly. Sediment here accumulates slowly, grain by grain over thousands of years. Every particle tells a story of descent from surface waters, from distant shores, from organisms that lived and died far above. In this sense, Challenger Deep is a collector, a quiet archive of the planet's biological history. What sinks eventually arrives here, and with it comes energy. Not much, just enough. Life at this depth survives on scarcity. There is no abundance, no excess. Energy arrives slowly, unpredictably. Every movement costs something. Every survival strategy is shaped by restraint. This is not a place for speed or waste. It is a place for patience. The creatures that inhabit Challenger Deep embody this patience. They do not rush. They do not compete aggressively. They persist. Their lives unfold at a pace that feels almost geological compared to our own. In the stillness of the abyss, time stretches. What's perhaps most remarkable is how unremarkable this life appears once we accept it. There are no monsters lurking here, no dramatic displays, just organisms doing what life has always done, adapting, surviving, continuing. The drama exists only in our expectations. Challenger Deep does not feel like a frontier in the heroic sense. It feels more like a reminder that Earth is older, stranger, and more capable than we often assume, that life does not need our permission or our understanding to exist. Standing, if one can imagine standing, at the bottom of the biosphere invites a quiet shift in perspective. From here, everything else on Earth lies above. Every forest, every city, every mountain peak. The deepest ocean floor holds the weight of the entire living world, both literally and metaphorically. And yet, life here is not crushed by that weight. It is shaped by it. Perhaps that is the most calming realization of all, that even at the deepest known point, under conditions that seem overwhelming, life finds a way to belong, not by resisting the environment, but by becoming part of it. As the thought settles, the abyss no longer feels like a void. It feels like a foundation, a place where the rules of life are written differently, but followed just as faithfully. And as we remain here a moment longer, suspended in this immense depth, another quiet question naturally forms. How does anything survive conditions that should, by all logic, destroy it? The answer begins not with life itself, but with the forces pressing in from all sides. The darkness, the cold, and the unimaginable pressure that define this world. Down here, the environment does not announce itself with sudden changes. There is no dramatic moment where conditions shift from survivable to impossible. Instead, everything becomes heavier, quieter, more restrained, as if the world itself is gently closing in. Pressure, darkness, and cold are not separate forces here. They blend into a single, constant presence. Pressure is the most difficult to imagine. It cannot be seen or heard. It is simply felt, everywhere, all at once. At the surface, our bodies live comfortably under a thin blanket of air. At this depth, that blanket has become an ocean pressing inward with relentless consistency. Thousands of atmospheres lean against every surface, every cell, every molecule, enough force to crush submarines, to fold steel, to turn fragile structures into nothing at all. From a human perspective, it feels final, as though this pressure represents a hard boundary, a firm statement from nature that says, no further. And yet, life here does not experience pressure as a threat. It experiences it as normal. That distinction matters. Pressure only destroys when something resists it. Anything with empty space, air pockets, rigid cavities, hollow structures becomes vulnerable. The deep ocean removes those weaknesses. Over time, evolution learns what pressure demands and responds not with strength, but with surrender. Structures become flexible, tissues become dense and fluid. Nothing fights the weight of the water. Everything yields to it. Darkness, too, feels absolute. This is not nightfall, where light retreats temporarily and returns again. This is a place where sunlight has never reached. Not once. Not ever. The sun exists here only as an abstract concept, remembered through the slow rain of organic matter drifting down from above. In such darkness, vision loses its importance. Eyes, if present at all, are often reduced, simplified, or repurposed. Some creatures abandon sight entirely. Others retain it in altered forms, tuned to detect the faintest glimmers of light rather than images. But many rely on entirely different senses: touch, vibration, chemistry, ways of knowing the world that do not depend on seeing it. Cold completes the trio. Temperatures at these depths hover just above freezing, and they barely change. There are no seasons here, no warmth carried by the sun. Cold is constant, but not harsh in the way we imagine cold on land. There is no wind to steal heat, no evaporation to chill the skin. Instead, the cold is stable, quiet, and enduring. Together, these conditions seem incompatible with life as we know it. Pressure that should collapse cells, darkness that removes the primary energy source for ecosystems, cold that slows chemical reactions to a crawl. And yet, life does not merely tolerate these forces, it is shaped by them. One might wonder, gently and without urgency, why these conditions do not simply erase life altogether. The answer is not dramatic. It is not a single adaptation or clever trick. It is accumulation. Small changes layered over immense spans of time, adjustments so subtle that no single generation notices them happening. At the molecular level, life here is tuned to its surroundings. Chemical reactions proceed more slowly, but they proceed reliably. Proteins fold differently. Membranes remain fluid despite the cold. Enzymes are built to function under pressure that would distort ordinary biological machinery. Nothing is rushed. Nothing is wasted. Darkness, rather than being an obstacle, becomes a stabilizing force. Without light, there are no daily cycles, no rhythms of day and night. Life settles into a steady pace, guided by availability rather than clocks. Energy arrives when it arrives. Movement happens when necessary. Stillness fills the rest. In this environment, extremes stop feeling extreme. They become background conditions, like gravity or time. Life here does not feel challenged by pressure or darkness any more than we feel challenged by the air around us. It simply exists within them. This reframing is important. The abyss is not actively hostile. It is indifferent. It does not seek to destroy life. It simply applies its rules consistently. Life that can follow those rules remains. Life that cannot fades away. Over millions of years, what remains is perfectly matched to the environment. There is a quiet elegance in that balance. No struggle, no drama, just compatibility. When early scientists imagined the deep ocean as uninhabitable, they assumed life required a narrow set of conditions. What the abyss reveals is that life is far more flexible than comfort would suggest. It does not demand warmth, or light, or gentle pressure. It demands stability and time. And stability is something the deep ocean has in abundance. The water at these depths moves slowly. Currents are gentle. Changes unfold over centuries rather than seasons. For life adapted to patience, this is not a harsh world. It is a predictable one. As the thought settles, the abyss begins to feel less like a place of punishment and more like a place of refinement. Pressure strips away fragility. Darkness removes distraction. Cold enforces efficiency. What remains is life distilled to its essentials. Perhaps this is why the deep ocean feels calming to imagine despite its severity. There is nothing sudden here, nothing loud, nothing chaotic, just a steady, unbroken presence that asks life to be honest about what it needs and nothing more. And as we drift gently through this understanding, another question arises naturally. If sunlight never reaches this world, if warmth and vision are absent, then what sustains life here at all? What replaces the sun when it disappears forever? The answer waits just above, in the moment where light finally fades and the ocean crosses a threshold from familiar blue into endless black. There comes a depth where the last traces of sunlight finally dissolve, not abruptly, but gently, as if the ocean is dimming the world on purpose. Colors fade one by one. Reds disappear first, then yellows, then greens, until even blue, the color most loyal to water, thins into nothing. What remains is not darkness as we experience it at night, but a kind of visual silence. This is the moment where life leaves the sun behind. Above, sunlight shapes everything. It fuels plants, drives weather, warms oceans, and sets the rhythm of days and seasons. Nearly all surface life, directly or indirectly, depends on its energy. It feels natural to assume that without the sun, life must end. And yet, as the ocean deepens and the light vanishes, life does not retreat. It adapts. The absence of sunlight changes the rules, but it does not erase them. Without light, photosynthesis becomes impossible. No plants grow here, no algae drift, no coral builds. The familiar base of the food web disappears. At first glance, this seems like the final barrier. How can life persist without a primary energy source? The answer begins with letting go of the idea that energy must arrive quickly or visibly. In the deep ocean, energy arrives slowly, quietly, almost invisibly. It comes from above, not as light, but as matter, tiny fragments of the surface world. Dead plankton, waste, shed cells, microscopic shells begin a long descent the moment they lose buoyancy. This steady fall is sometimes called marine snow, but here it feels less like snow and more like time itself drifting downward. Each particle carries stored energy from sunlight absorbed long ago. By the time it reaches the deep, that energy is old, diluted, and scarce, but it is still usable. Life here learns to live on leftovers, and not just leftovers from one moment, but from the entire ocean above. Every ecosystem on the surface contributes, unknowingly, to the deep. Every breath, every bloom, every death sends something downward. The abyss becomes a quiet receiver, collecting what the rest of the world releases. This shift from light to matter reshapes life completely. In a sunlit world, growth can be fast. Energy is abundant. Competition is intense. In the darkness, speed loses its advantage. Efficiency becomes everything. Creatures grow slowly, move deliberately, and waste almost nothing. Every calorie is accounted for. Every opportunity is used fully. It's tempting to imagine this as a bleak existence, but there is another way to see it. Without light, there are no sudden changes, no droughts or floods driven by weather, no fires, no seasonal die-offs. Life settles into a steady rhythm, guided not by cycles of brightness and shadow, but by availability and patience. Some organisms never experience a dawn or dusk. Their entire existence unfolds in a world where time is measured not in days, but in chemical gradients and slow arrivals of food. The concept of day simply does not exist here, and yet life continues to sense its surroundings with remarkable sensitivity. Chemical traces in the water become signals, vibrations become messages, pressure changes carry meaning. Without sight, awareness expands rather than contracts. The sun's absence also removes warmth, but here again, life adjusts. Chemical reactions slow, but they do not stop. Metabolism becomes measured. Growth stretches across years, sometimes decades. Longevity increases not because life is easy, but because it is unhurried. One might wonder, quietly, whether this kind of existence feels diminished or enriched. Without light, without color, without rapid change, does life lose something essential, or does it gain something else entirely? In the deep ocean, there is no rush, no urgency imposed by sunrise or sunset, no need to grow quickly before winter comes. Life unfolds at its own pace, shaped by consistency rather than fluctuation. There is a kind of calm built into the environment itself. Leaving the sun behind also means leaving behind many of the dangers associated with it. Ultraviolet radiation never reaches these depths. Surface disturbances fade away. Even human noise struggles to penetrate fully. The abyss becomes insulated, protected by miles of water above it. This insulation creates a sense of permanence. While the surface world changes rapidly, climates shifting, coastlines reshaping, the deep remains remarkably stable. Conditions that existed millions of years ago persist today with little alteration. Life here evolves slowly but steadily, guided by long-term consistency. As this idea settles, the absence of sunlight begins to feel less like a loss and more like a transformation. Energy does not disappear, it changes form. Time does not vanish, it stretches. Sensation does not fade, it adapts. And somewhere in this dark, weightless world, life finds ways to persist that do not resemble anything familiar from above. This realization opens a quiet door in the mind. If life can thrive without sunlight here, then perhaps light was never the only path. Perhaps energy in all its forms can sustain ecosystems far beyond the narrow conditions we once imagined. The abyss becomes not a place where life ends, but a place where it reinvents itself. As we drift deeper into this understanding, the ocean continues downward, beyond the last echo of the sun, into regions defined entirely by pressure and chemistry. This realm has a name, a zone so extreme it stands apart even within the deep ocean itself. And in that zone, life continues to challenge everything we thought we knew about, where survival should be possible. Below the regions most people imagine when they think of the deep ocean, there exists a layer so extreme that it feels set apart, almost sealed off from the rest of the world. This is the Hadal zone, named after the ancient idea of the underworld, not because it is sinister, but because it lies so far beyond ordinary reach that it once felt mythical. The Hadal zone begins where even the deep becomes deeper. It starts around 6 kilometers below the surface and extends all the way down to the deepest trenches carved into Earth's crust. Only a small fraction of the ocean belongs to this zone, yet it represents some of the most intense conditions on the planet. Pressure here is no longer just immense, it is defining. Darkness is no longer a condition, it is the default state of existence. For a long time, this zone was excluded from biological thinking altogether. Maps showed it clearly, depth charts acknowledged it, but life was assumed to stop before reaching this far down. The Hadal zone was treated like a geological footnote rather than a living space. And yet the ocean does not recognize our categories. The Hadal zone is not an extension of the abyssal plains above it. It is shaped differently, behaves differently, and demands a different kind of resilience. Trenches act like funnels, gathering organic material from vast areas of the ocean and concentrating it in narrow, deep spaces. What sinks anywhere nearby eventually finds its way here. In this sense, the Hadal zone is both isolated and connected, cut off from light, but linked to the entire ocean through gravity. The water here is astonishingly still, currents slow to a near standstill. Movement happens, but it is subtle, patient, measured over long periods of time. Sediments accumulate gently, creating soft, uneven floors that record thousands of years of quiet descent. Nothing is hurried, nothing is disturbed unless something external intrudes. Pressure in the Hadal zone is so constant that it stops feeling like pressure at all. For organisms adapted to this depth, it is simply the way things are. There is no contrast, no relief, no variation. The water presses inward with the same force, day after day, century after century. Stability replaces comfort. It is this stability that makes life here possible. Life does not need ease, it needs consistency. The Hadal zone offers that in abundance. Temperatures barely fluctuate. Chemical conditions remain steady. There are no storms, no waves, no seasonal shifts. For evolution, this is fertile ground, not because it encourages rapid change, but because it allows precise refinement. Creatures that inhabit the Hadal zone are not generalized survivors. They are specialists, shaped by a narrow range of conditions so extreme that few competitors can follow. This isolation reduces competition and allows life to persist in small, scattered populations that would never survive in more crowded environments. One might imagine this as a lonely existence, but loneliness is a surface world idea. In the Hadal zone, distance is normal. Encounters are rare. Interaction is minimal. Life is not social here. It is situational. Organisms cross paths when circumstances align, not because they seek one another out. And still, life exists. The Hadal zone forces us to reconsider what an ecosystem looks like. There are no forests, no reefs, no obvious structures. Instead, there is a network of chemical exchanges, microbial foundations, and slow-moving scavengers tied together by the gradual arrival of energy from above. It is an ecosystem stretched thin, but not broken. The idea that this zone exists at all is humbling. It reminds us that Earth is not built solely for visibility or accessibility. Large portions of the planet operate entirely outside human experience, governed by rules we are only beginning to understand. The Hadal zone is one such realm, a place that does not announce itself, does not invite exploration, and does not change to suit our expectations. And yet, when we finally reach it with our instruments and machines, it does not reject us. It simply continues being what it has always been. There is something quietly poetic about the fact that the deepest places on Earth are not barren, but even here, beneath kilometers of water and unimaginable pressure, life finds a way to persist without drama or spectacle. It does not glow brightly or announce its presence. It simply exists, fulfilling its role in a system far larger than itself. The Hadal zone also reshapes how we think about limits. It shows that boundaries are often temporary markers of knowledge rather than true endpoints. Each time, technology allows us to look deeper. The line moves. What was once impossible becomes merely unexplored. This realization does not demand urgency. It invites patience. The Hadal zone is not something to be conquered or rushed through. It is something to be approached slowly, carefully, with respect for its pace and scale. As we linger in this understanding, the Hadal zone begins to feel less like an underworld and more like a hidden foundation, a place where life operates at the margins, quietly supporting the larger oceanic system without ever being noticed. And within this zone, against all expectation, discoveries began to emerge. Small, subtle signs that life was not merely present, but established. These findings did not arrive loudly. They surfaced gradually, as instruments recorded movement where none was expected, as samples revealed organisms adapted to pressures once thought unsurvivable. The Hadal zone, it turned out, was not empty. It was simply patient. And as that patience met human curiosity, something profound happened. Biology itself had to expand. Textbooks had to change. Assumptions had to soften. Because life, once again, had quietly crossed a boundary we believed was firm. The deeper we look into this zone, the clearer it becomes that the ocean's most extreme environments are not exceptions to life's story. They are part of it. And the Hadal zone, far from being a dead end, becomes one of its most revealing chapters. One that shows how far life can go when given enough time, enough stability, and just enough energy to continue. At some point, the idea that life belongs only in gentle places begins to feel incomplete. The Hadal zone makes that clear, not through spectacle, but through persistence. What was once assumed to be an empty margin reveals itself as quietly inhabited, and that realization carries a subtle weight. It asks us to reconsider not just where life can exist, but how we define existence itself. The first confirmations of life at these depths did not arrive as dramatic discoveries. There were no sudden crowds of organisms filling the frame. Instead, there were small signs, patterns in the sediment that suggested movement, faint biological signatures in samples, traces of metabolism where only inert chemistry was expected. At first, these hints were easy to dismiss. Contamination, perhaps. Misinterpretation. Instruments had been wrong before, but the signs persisted. Again and again, expeditions returned with evidence that something was living, functioning and reproducing in the Hadal zone. Microorganisms embedded in the mud. Tiny crustaceans appearing on baited cameras. Creatures not just passing through, but clearly adapted to remain. Each confirmation added a quiet layer of certainty, until the idea of a lifeless abyss could no longer hold. This was not merely an extension of known biology into deeper water. It was a challenge to the assumptions that shaped biology in the first place. For centuries, life had been defined by its reliance on sunlight, moderate temperatures, and manageable pressure. Even when life was found in extreme places, hot springs, frozen tundra, acidic lakes, it was often framed as an exception. The Hadal zone, however, was not an exception. It was an entire environment operating by different rules. Life here does not cling to survival. It is built for it. What makes this realization so powerful is not the number of species discovered, but the implications behind them. If life can persist under thousands of atmospheres of pressure, in perpetual darkness, at near freezing temperatures, then the boundaries we once drew around habitability were never as solid as we believed. They were conveniences, shaped by our own environment rather than by life's true potential. The organisms of the Hadal zone are not struggling against their surroundings, they are in harmony with them. Their bodies reflect the pressures they endure. Their chemistry mirrors the cold they inhabit. Their behaviors align with scarcity and stillness. There is no sign of distress, no indication that they exist on the edge of collapse. They simply live. This quiet normalcy is perhaps the most surprising part. One might expect life in such an extreme environment to feel fragile, constantly at risk. But fragility is a surface world concept. In the Hadal zone, resilience is built into every layer of existence. Evolution has had millions of years to experiment here, refining forms that do not resist the environment, but integrate with it. In this way, the Hadal zone becomes a place where biology feels almost distilled. Extraneous features fall away. What remains is function, simple, effective, and deeply adapted. The discovery of life here forced scientists to expand their thinking, not just about Earth, but about life elsewhere. If organisms can thrive without sunlight, under immense pressure, sustained by chemistry rather than warmth, then the potential habitats for life in the universe grow wider. Moons with subsurface oceans, planets with thick ice shells, worlds once dismissed as sterile suddenly feel less certain. But even without looking outward, Earth alone offers enough wonder. The Hadal zone reminds us that life does not announce its presence. It does not seek attention. It unfolds quietly, often beyond our notice, filling niches we never thought to look for. The absence of visibility does not equal absence of activity. Stillness does not mean emptiness. As evidence accumulated, the narrative shifted. Textbooks were revised, diagrams extended downward. The biosphere was redrawn to include places once shaded out, or labeled simply unknown. The boundary between living and non-living Earth moved deeper, following life where it had already gone. This shift did not diminish the mystery of the deep ocean. It deepened it, because with every discovery came new questions. How many species remain unseen? How long have they been there? How do they interact in an environment so sparse and quiet? The Hadal zone does not offer quick answers. It offers patience. Life here operates on timescales that stretch beyond human intuition. Growth is slow, reproduction is measured, change happens gradually. In such a setting, existence is not about rapid expansion or dominance. It is about continuity. And perhaps that is why the idea of life here feels so grounding. It strips survival down to its essence. No excess, no urgency, just the steady continuation of living systems, shaped by their environment rather than opposed to it. As this understanding settles, the phrase "where life should not exist" begins to lose its meaning. It reveals itself as a reflection of our expectations rather than a statement of fact. Life does not consult our assumptions. It explores possibilities we overlook. The Hadal zone teaches this lesson gently. It does not shock us with overwhelming abundance. It invites us to pay attention to subtle signs, to notice small movements, to recognize that life, when given time, will explore every available space. And in that quiet exploration, it leaves behind a trail of reminders that the planet is more alive than it appears, that boundaries are often illusions, and that even in the deepest, darkest places, existence continues, not loudly, not dramatically, but faithfully. As instruments lingered on the seafloor, as cameras adjusted to darkness, something else became apparent. The life here was not only present, it moved, slowly, deliberately, leaving traces that hinted at a deeper story still unfolding in the dark. When cameras first reached the deepest seafloor, there was an expectation, quiet, cautious, but present, that nothing would happen, that the lens would stare into darkness and receive only darkness in return. After all, if life existed here at all, it would be sparse, perhaps motionless, perhaps too subtle to register. The machines were lowered carefully, lights dimmed to avoid disturbance, and then the waiting began. At first, there was only stillness. Sediment lay undisturbed, fine and pale, shaped into gentle ripples by currents too slow to notice. The darkness felt complete, absorbing the light rather than reflecting it. Time passed in long, quiet minutes. Nothing moved. Nothing announced itself. And then, almost imperceptibly, something shifted. Not a sudden appearance, not a dramatic entrance, just a slight rearrangement of grains, as if the seafloor itself had exhaled. A soft indentation where there had been none. A faint trail, barely visible, winding across the mud. These were not images that shouted discovery, they whispered it. Movement in the abyss does not resemble movement at the surface. There is no darting, no sudden acceleration. Energy is too precious for that. Instead, motion unfolds slowly, deliberately, like a thought forming over time. The first explorers learned quickly that patience was essential. Blink, metaphorically, and you might miss everything. As cameras remained still, the seafloor began to reveal itself not as inert, but as quietly active. Tiny organisms emerged from beneath the sediment, leaving faint tracks behind them. Small shapes approached bait with cautious restraint, testing the water before committing to contact. Life here did not rush toward opportunity. It approached it carefully. This subtlety changed how observation itself had to be practiced. Traditional exploration looks for obvious signs, movement, color, contrast. In the Hadal zone, those cues are muted or absent. Discovery depends on noticing what changes slowly, rather than what appears suddenly. A track across the mud might take hours to form. A feeding event might unfold over an entire day. The deep ocean does not perform for an audience. It requires presence. One of the most striking realizations from these early observations was that the seafloor was not static. It was shaped continuously by living things. Sediment was being stirred, redistributed, processed. Trails crisscrossed the mud in faint patterns, evidence of organisms moving just beneath the surface. Unseen, but unmistakably there. These movements told stories without words. They revealed feeding behaviors, territorial boundaries, and habitual paths repeated over time. They showed that even in near total darkness, life leaves signatures of its existence, not through sound or color, but through contact. There was something deeply calming about these discoveries. The movements were not frantic. They were not defensive. They carried no urgency. Instead, they suggested a world operating at a different tempo, where survival is not a race, but a long, steady process. Occasionally, a shape would drift into the edge of the camera's light, an amphipod gliding slowly, a fish hovering with minimal effort, its body barely moving as it balanced against the water. These moments felt almost intimate, as if the ocean were allowing a brief glimpse rather than offering a display. The organisms did not react dramatically to the lights. Some paused, some retreated slightly, others seemed indifferent. This lack of alarm suggested something important. Encounters here are rare. There is little reason to panic when movement is so infrequent and energy so conserved. In this environment, stillness is not a sign of death. It is a strategy. What surprised many observers was how intentional the movement appeared. Every shift seemed purposeful. Nothing wandered aimlessly. When something moved, it did so for a reason: to feed, to adjust position, to respond to a subtle change in pressure or chemistry. Randomness, so common at the surface, felt reduced here. This sense of intention may be an illusion shaped by scarcity, but it leaves a lasting impression. The abyss feels thoughtful, measured, almost contemplative. Life here does not waste motion, because motion costs too much. As more footage accumulated, patterns emerged. Certain areas showed repeated activity, suggesting favored feeding grounds. Other regions remained untouched for long periods, their sediments smooth and undisturbed. The seafloor revealed a kind of geography defined not by landmarks, but by use. Even the absence of movement became informative. Long stretches of stillness hinted at areas where food rarely arrived, where life waited patiently, conserving energy until conditions shifted. Waiting here is not passive, it is active restraint. There is something quietly profound about realizing that the first signs of life in Earth's deepest places were not dramatic encounters, but gentle disturbances in mud. It reframes discovery itself. It suggests that understanding does not always arrive through spectacle, but through attention. As observers learn to slow down, to watch without expectation, the abyss began to speak in its own language, a language of pressure marks and subtle tracks, of pauses and small adjustments, of life expressed not through abundance, but through persistence. These early signs of movement confirmed something essential. Life at the bottom of the ocean is not frozen in place. It is not dormant or suspended. It is active, engaged, responding continuously to its environment. Even if that response unfolds at a pace far slower than we are used to, the realization settles gently. The abyss is not waiting, it is living. And as the eye adjusts, not to light, but to patience, more becomes visible. Shapes, once dismissed as rocks, reveal themselves as organisms resting. Slight motions hint at bodies adapted to hover, to blend, to endure. The deep teaches a new kind of seeing, one that values subtlety over speed. From these first signs of movement, curiosity deepens. If life here moves so deliberately, so quietly, what forms has it taken? What bodies are shaped not for speed or strength, but for survival under crushing weight? The answer begins to appear in one of the most unlikely forms imaginable. A fish that looks almost unfinished, delicate to the point of fragility, yet perfectly suited to the deepest waters on Earth. When the cameras finally lingered long enough, when the eyes watching learned how to wait, a shape emerged that seemed almost out of place. It did not glide with sharp lines or armored confidence, did not look powerful or imposing. Instead, it appeared soft, pale, and strangely delicate, as if the ocean had sketched it lightly, and then stopped. This was the Hadal snailfish. At first glance, it is easy to misunderstand this creature. Its body looks gelatinous, its skin translucent, its features understated, There is nothing about it that suggests dominance or endurance. To a surface world eye, it appears unfinished, almost fragile, as though it might fall apart if lifted from the water. And that is exactly why it survives. The Hadal snailfish is not built to resist pressure. It is built to belong to it. Its body contains no rigid structures that pressure can crush. Its tissues are soft and flexible, yielding gently to the immense weight of the water around it. Where strength would fail, softness succeeds. In the crushing depths of the Hadal zone, rigidity is a liability. Anything stiff becomes a point of failure. Anything hollow becomes vulnerable. The snailfish avoids these dangers, not by reinforcement, but by simplicity. It has let go of what it does not need. Its bones, where present at all, are thin and lightly structured. Its muscles are adapted for slow, efficient movement rather than bursts of speed. Its body fluids are carefully balanced to match the surrounding pressure, eliminating stress at the cellular level. Nothing pushes outward. Nothing collapses inward. Everything is in quiet equilibrium. This balance gives the snailfish a strange kind of grace. It does not swim so much as hover, adjusting its position with minimal effort. Movement is subtle, economical, almost meditative. In a world where energy is scarce, this restraint is survival. What's remarkable is that this fish does not merely endure the Hadal zone. It thrives there. It has been observed feeding, navigating, and interacting with its environment in ways that suggest long-term adaptation rather than temporary tolerance. It is not visiting, it is at home. The snailfish feeds primarily on small invertebrates, particularly amphipods that gather wherever organic material accumulates. These prey items are themselves adapted to the deep, forming a slow, quiet food web that operates without urgency. The snailfish waits, watches, and responds when opportunity arises. Its sensory world is tuned to darkness. Vision, if present, plays a minor role. Instead, the snailfish relies on subtle pressure changes, vibrations and chemical cues carried through the water. In the absence of light, information travels differently. The snailfish listens to the ocean rather than looking at it. There is something almost poetic about the idea that the deepest living fish on Earth looks nothing like what we expect a survivor to look like. It is not armored. It is not fast. It is not aggressive. It is soft, understated, and calm. This challenges a deeply ingrained assumption that survival requires hardness, speed, and strength. In the Hadal zone, those traits offer little advantage. What matters instead is harmony with the environment. The snailfish embodies that harmony completely. It is also a reminder of how misleading appearances can be. Removed from its environment, the snailfish would not survive. Its body would collapse under the absence of pressure. What looks fragile is actually perfectly optimized, but only for the world it belongs to. This specificity is important. The snailfish is not a generalist. It cannot move freely between depths. It is bound to its environment as much as it is supported by it. This deep specialization tells a story of long evolution, of generations shaped slowly by constant conditions. When scientists first observed snailfish at such depths, it forced a reconsideration of where fish as a group could exist. Fish had long been associated with more moderate depths, where pressure and temperature still allowed familiar forms. The Hadal snailfish pushed that boundary downward, demonstrating that even vertebrates, animals with backbones, could adapt to the most extreme marine environments on Earth. And yet, the snailfish does not feel like an outlier. It feels like a natural outcome. Given enough time, life explores every available option. Where rigidity fails, softness emerges. Where speed wastes energy, stillness prevails. Watching the snailfish hover in the darkness, one cannot help but feel a quiet sense of respect. It is not dramatic. It does not perform. It simply exists, perfectly matched to conditions that once seemed unlivable. In its presence, the Hadal zone feels less alien. The extreme becomes familiar. The impossible becomes ordinary. The snailfish also hints at something deeper. If such a creature can exist here, what other forms might remain unseen? What other solutions has evolution discovered in the dark, far beyond our reach? The Hadal zone has been visited only briefly, observed only in fragments. Most of its life remains undocumented, unnamed, unknown. This uncertainty does not feel unsettling, it feels appropriate. The deep ocean is not a place that yields its secrets quickly. It reveals them slowly, to those willing to wait and observe without expectation. As the snailfish drifts out of view, blending once more into darkness, it leaves behind a lingering impression that survival does not always look like triumph. Sometimes it looks like quiet adaptation, like letting go of unnecessary strength, like becoming soft enough to endure what cannot be resisted. And as this understanding settles, the focus shifts from individual creatures to the bodies they inhabit, to the ways life in the abyss has reshaped itself at the most fundamental level, not to fight pressure, but to dissolve into it. In the deep ocean, the word crushed takes on a different meaning. It no longer describes a sudden collapse or violent destruction. Instead, it becomes a constant condition, a steady presence pressing in from all directions. Life here does not fear this pressure. It is shaped by it, molded quietly over time into forms that make resistance unnecessary. To understand how bodies survive here, it helps to let go of how bodies work at the surface. On land, and even in shallow water, living things are full of empty spaces. Lungs hold air, sinuses trap pockets of gas, bones form rigid frames around hollow interiors. These spaces make movement efficient and breathing possible. But they also create weakness. Under extreme pressure, empty space is a liability. In the abyss, life removes those liabilities. Deep sea organisms are dense in a way that feels almost counterintuitive. Their tissues are tightly packed with fluid. Their bodies are often filled with substances that match the surrounding seawater so closely that pressure passes through them without resistance. There is nothing for the water to push against, nothing to collapse. This is not armor, it is alignment. By eliminating air-filled cavities, these creatures become almost invisible to pressure. The force of the ocean does not press them inward. It simply exists around them. Pressure becomes neutral, no more threatening than gravity is to us. This quiet compatibility allows life to persist where brute strength never could. Even internal systems adapt. Circulation slows. Gas exchange, where it exists at all, is carefully regulated. Buoyancy is controlled not by air bladders, but by subtle differences in tissue composition and body shape. Floating becomes a matter of balance rather than inflation. This design results in bodies that feel soft, pliable, almost liquid. To human eyes, accustomed to rigidity as a sign of strength, these forms can look fragile, but fragility depends on context. In the Hadal zone, softness is resilience. There is a calm logic to this. Pressure is uniform here. It presses equally from all sides. The most efficient response is not to resist, but to yield evenly. Life learns to distribute itself within that force, becoming something pressure can move through rather than act upon. This principle applies across many forms of life in the deep: crustaceans with flexible exoskeletons, fish with reduced bone density, invertebrates with bodies that shift shape without damage. Each adaptation is a variation on the same theme: remove the points of failure. What's striking is how little excess remains. These bodies are not built for speed or power. They are built for survival with minimal energy. Muscle fibers are arranged for slow, sustained movement. Joints are simple. Structures that would be useful in brighter, warmer waters quietly disappear. In the abyss, evolution is less about adding features and more about subtracting them. This subtraction does not diminish life, it clarifies it. Each remaining structure serves a purpose. Each system is tuned to operate efficiently under conditions that never change. There is no need for versatility when the environment is constant. There is no benefit in preparing for extremes when the extreme is always present. One might imagine this leads to monotony, but the opposite is true. Within these narrow constraints, life becomes incredibly precise. Tiny differences in chemistry, shape, or behavior can determine survival. Small adjustments matter here more than grand innovations. Bodies built to be crushed are also bodies built to last. Without rigid structures to fracture, without air spaces to implode, these organisms can endure pressure indefinitely. Time becomes less of an enemy. Many deep-sea creatures live far longer than their surface relatives, their slow metabolisms and stable environments reducing the wear that shortens lives elsewhere. There is something deeply grounding about this idea, that survival at the edge of possibility does not require constant struggle. It requires fit. It requires acceptance of conditions rather than opposition to them. The abyss teaches this lesson again and again. Life does not conquer pressure. It dissolves into it. It does not push back against the weight of the ocean. It becomes indistinguishable from it. This way of existing feels unfamiliar to us because our lives are shaped by change. We adapt to shifting seasons, fluctuating temperatures, unpredictable events. The deep ocean offers none of that. It offers consistency, and in that consistency, life simplifies. As we reflect on these bodies, shaped not for resistance, but for coexistence, the abyss feels less threatening. It becomes a place of quiet agreement between life and environment, a place where survival is not dramatic, but continuous. And yet, beneath this softness lies remarkable strength, not the kind that defies force, but the kind that endures it endlessly. This understanding leads naturally to another subtle shift. If bodies here are soft by design, if rigidity is avoided rather than reinforced, then even the skeleton itself must be reimagined. Bones, tissues, and structures follow different rules in a world where pressure never relents. And in that world, flexibility becomes not a weakness, but the deepest form of strength. In the deepest reaches of the ocean, strength does not announce itself through hardness. It reveals itself through flexibility. The structures that survive here are not those that stand firm, but those that bend without breaking, that shift without shattering, that move with the ocean rather than against it. Bones, as we understand them on land, are symbols of stability. They give shape, leverage, protection. But in the abyss, rigidity carries risk. A stiff structure concentrates stress. Under constant pressure, stress seeks an exit point. And when it finds one, failure follows. Life here avoids that trap by rewriting what a skeleton can be. Many deep-sea creatures possess bones that are thinner, less mineralized, and more elastic than those of their shallow water relatives. Some have skeletons that feel almost rubbery by comparison. Others reduce bone altogether, relying instead on cartilage or soft tissue to provide just enough structure to move and feed. This softness is not weakness. It is adaptation refined to precision. Flexible bones distribute pressure evenly. They do not crack when compressed. They yield slightly, absorbing force and returning to shape without damage. In an environment where pressure never lets up, this elasticity is essential. It turns a crushing force into a constant background, something to exist within rather than endure. Soft tissue plays a similar role. Muscles in the abyss are not built for explosive movement. They are built for endurance and efficiency. Fibers are arranged to minimize energy loss, contracting slowly and deliberately. Every motion is measured, conserving precious calories in a world where food arrives infrequently. Even connective tissues adapt, becoming more gelatinous, more fluid-filled. This composition allows organs to shift gently under pressure, without tearing. The body becomes less like a machine with rigid parts and more like a cohesive whole, integrated, adaptable, and resilient. There is a quiet elegance to this design. Nothing is excessive, nothing is ornamental. Every structure exists because it serves a purpose in this specific environment. Evolution here is not about pushing boundaries outward, but about fitting inward, aligning perfectly with the forces at play. One might imagine such softness would make movement clumsy or imprecise. In reality, it creates a different kind of control. Motion becomes smooth, continuous, almost effortless. Instead of sharp angles and sudden stops, movement flows. Creatures glide, hover, and adjust position with minimal disturbance to the surrounding water. This fluidity has another advantage. It leaves fewer traces. In a world where encounters are rare, not advertising one's presence can be beneficial. Soft bodies move quietly, displacing less water, sending fewer vibrations through the dark. Silence here is safety. Even protective structures change. Spines and hard shells, so common in shallower waters, become less useful. Building and maintaining them requires energy that is better spent elsewhere. Many deep-sea animals trade physical defense for invisibility and endurance, relying on scarcity and stillness to avoid threats. The concept of support also shifts. On land, skeletons hold bodies upright against gravity. In water, buoyancy shares that burden. In the deep, where buoyancy is carefully balanced, bodies are supported by the water itself. Skeletons need only provide guidance, not load-bearing strength. This relationship between body and environment feels almost cooperative. The ocean carries the weight. The organism shapes itself to be carried. There is something quietly comforting about this idea, that survival does not require standing alone or holding firm at all costs. That sometimes resilience means allowing oneself to be supported by the conditions around you, even when those conditions feel overwhelming. As we drift through this understanding, the abyss begins to feel less alien. Its rules are different, but they are not cruel. They are consistent. Life responds not with struggle, but with elegance. The flexibility seen in bones and tissues also hints at something deeper. Adaptation not just in form, but in chemistry. For softness to persist under such pressure, the very molecules that make up these bodies must behave differently. Proteins must fold in stable ways. Cell membranes must remain fluid. Enzymes must continue working despite forces that would distort them elsewhere. The body at every level becomes a conversation between biology and physics. This layered adaptation, bones yielding, tissues flowing, molecules adjusting, creates organisms that feel almost inseparable from their environment. They are not visitors to the deep ocean. They are expressions of it. And as this thought settles, another quiet curiosity arises. If bones and tissues can adapt so completely, what about the smallest building blocks of life? How do proteins, enzymes, and cellular machinery continue to function when pressure alone could unravel them? The answer lies deeper still, in chemistry shaped by darkness and weight, where even the invisible components of life learn how to bend without breaking. Beneath the softness of bodies and the flexibility of bones lies a quieter adaptation, one that cannot be seen even in the brightest light. It exists at a scale too small for shape or movement, yet it determines whether life can continue at all. In the abyss, survival depends not just on form, but on chemistry, on proteins that remain calm and functional under crushing weight. Proteins are the working tools of life. They fold into precise shapes that allow cells to breathe, digest, repair, and communicate. At the surface, these shapes are held together delicately, balanced by temperature and pressure within a narrow range. Change that balance too much, and proteins unravel. When they unravel, life stops. In the Hadal zone, pressure presses on these molecules constantly. It does not pause. It does not fluctuate. It bears down with a force that elsewhere would twist proteins out of shape and render them useless. And yet, here they continue to work, quietly and reliably. The key is not resistance, but stability. Proteins in deep-sea organisms are subtly different from their surface counterparts. Their amino acid sequences, the tiny chains that determine how they fold, are arranged in ways that favor compactness and flexibility at the same time. They fold more tightly, leaving fewer gaps for pressure to exploit. Yet they remain supple enough to shift slightly without breaking apart. This balance is delicate, but it is remarkably effective. Instead of snapping or stiffening under pressure, these proteins adjust. Their structures hold together not because they are rigid, but because they are adaptable. Inside cells, additional molecules help maintain this stability. Certain compounds act like gentle supports, surrounding proteins and buffering them against pressure-induced distortion. These molecules do not interfere with function. They simply create a chemical environment where folding remains reliable even under thousands of atmospheres. It is easy to overlook this level of adaptation because it happens silently. There is no visible motion, no dramatic transformation, and yet, without it, nothing else would matter. Muscles could not contract, nerves could not signal, cells could not divide. Life would freeze at the molecular level. What's striking is how ordinary this chemistry becomes once it is established. For organisms living here, precious stable proteins are not a special feature. They are the default. There is no sense of strain or effort. Reactions proceed at their own pace, slower than at the surface, but steady and predictable. This steadiness shapes everything else. Metabolism becomes unhurried. Energy use is efficient. Growth is gradual. Life unfolds without urgency because the chemistry allows it to. The cold of the deep ocean adds another layer to this molecular calm. Low temperatures, slow reactions, but proteins here are tuned to function without haste. They are not designed for speed. They are designed for reliability. Each reaction happens when it happens, without waste. In this way, the abyss teaches a quiet lesson about endurance. Speed is not required. Excess is unnecessary. What matters is consistency. These molecular adaptations also reveal something profound about evolution. They did not appear suddenly. They emerged gradually, through countless small adjustments over immense spans of time. Each generation carried slight improvements. Proteins that folded a bit more reliably, enzymes that functioned a bit more smoothly under pressure. Over millions of years, these small advantages accumulated into a chemistry perfectly suited to the deep. This process is slow, but it is patient. The Hadal zone does not reward rapid change. It rewards precision. There is something almost meditative about imagining this microscopic world. Molecules drifting gently within cells, folding and unfolding with calm regularity, unaffected by the immense forces pressing in from all sides. While the ocean above roils with storms and tides, this inner world remains steady. It invites a shift in perspective. The deepest resilience does not always come from visible strength. Sometimes it comes from quiet stability at the smallest scales. As we linger on this idea, the abyss begins to feel less like a place of constant stress and more like a place of balance. Pressure is high, yes, but it is consistent. Cold is present, but it is stable. In such an environment, chemistry can settle into reliable patterns. This reliability allows life to build upward. From stable proteins come stable cells. From stable cells come tissues. From tissues come bodies that can move, feed, and reproduce. The foundation is invisible, but everything rests upon it. It is also worth noticing how this challenges our intuition about fragility. We often think of life as delicate, easily disrupted, and in many environments that is true. But in the abyss, life is delicate in appearance yet robust in function. Its resilience is not loud, it is embedded. This embedded resilience carries implications beyond the ocean. It suggests that life, given enough time, can adapt its most fundamental processes to conditions far outside our everyday experience. It suggests that the boundaries we imagine, too much pressure, too little warmth, are not absolute. They are invitations for chemistry to try something new. As this understanding settles, attention drifts outward again, from molecules to the creatures they sustain. With stable chemistry and soft bodies, life in the deep takes on forms that feel both familiar and strange. Some of these forms grow larger than expected, their size shaped not by abundance, but by scarcity and patience. In the darkness below, where food arrives rarely and unpredictably, even scavengers follow rules that feel counterintuitive. And among them are creatures whose size tells a story of survival written slowly, in a world where nothing is rushed and everything is reused. In a place where food is scarce and arrivals are unpredictable, size begins to mean something different. At the surface, growing large often requires abundance, plenty of energy, constant feeding, competition that rewards speed and strength. In the abyss, the rules shift. Here, largeness can emerge not from excess, but from patience. This is where giant amphipods appear. At first, the word giant feels misleading. These creatures are not enormous in the way whales are enormous. They are not towering or dominant, but compared to their shallow water relatives, small shrimp-like scavengers that live unnoticed along coasts and reefs, Hadal amphipods are startlingly large. Some reach the length of a human hand, others larger still, their pale bodies curving gently as they move. They look like creatures borrowed from a different scale, as if the deep ocean quietly adjusted the volume knob on size and left everything else unchanged. Amphipods are scavengers by nature. They feed on what falls, what drifts, what arrives too late to be eaten elsewhere. In the Hadal zone, this role becomes central. There is no constant supply of food. Instead, there are long stretches of waiting, punctuated by rare events: a dead fish sinking from above, a piece of organic debris finally reaching the bottom after weeks or months of descent. When something does arrive, it must be used fully. Large size helps with that. A bigger body can store more energy, allowing amphipods to survive long periods without feeding. Fat reserves build slowly, then are drawn down patiently over time. In this way, size becomes a buffer against uncertainty. It allows life to stretch itself across gaps in availability. There is also the matter of efficiency. Larger amphipods can travel farther with less relative energy cost, gliding slowly across the seafloor in search of opportunity. Their movements are deliberate, unhurried. There is no frantic searching, just steady exploration, guided by chemical traces carried faintly through the water. When food is detected, amphipods gather, not in chaotic swarms, but in calm congregations. They approach cautiously, each movement measured. Feeding unfolds over hours, sometimes days. Nothing is wasted. Every accessible nutrient is consumed. In a world where meals are rare, thoroughness matters. Their bodies reflect this lifestyle. Exoskeletons are flexible rather than brittle, allowing them to withstand pressure without cracking. Appendages are strong enough to grip and tear, but not overly specialized. Versatility is more useful than speed here. Despite their size, giant amphipods are not aggressive. They do not hunt. They wait. Their existence is shaped by patience rather than pursuit. In this way, they feel perfectly matched to the rhythm of the deep. There is something quietly reassuring about that rhythm. Life here does not rush toward growth or reproduction. It accumulates slowly, step by step, over long spans of time. Size is earned gradually, not forced. The presence of giant amphipods also reveals something important about deep-sea ecosystems. Even in extreme environments, food webs exist. They may be sparse and stretched thin, but they are functional. Scavengers play a vital role, recycling nutrients and redistributing energy across the seafloor. Without them, organic material would accumulate unused, locked away in sediments. With them, energy continues to flow, even at the bottom of the ocean. Life supports life, quietly and efficiently. It is easy to imagine the Hadal zone as static, but amphipods remind us that it is dynamic in its own slow way. When food arrives, activity increases. When it is gone, stillness returns. This pulse, long pauses followed by gentle bursts of movement, defines much of life here. There is also an intimacy to these events. In the darkness, creatures respond to the same signals, drawn together briefly by opportunity. Encounters are rare, but meaningful. When they happen, they matter. Giant amphipods do not dominate their environment. They participate in it. Their size does not grant them control. It grants them endurance. They are living reservoirs of energy, bridges between moments of abundance and long periods of scarcity. This way of living challenges surface world assumptions once again. Bigger is not always faster. Stronger is not always louder. Sometimes, bigger simply means better prepared to wait. As we linger with this idea, the abyss begins to feel less barren. It feels like a place where life has learned to stretch itself across time rather than space, where survival is measured not in daily success, but in long-term balance. And yet, even giant amphipods do not create energy on their own. They depend on something else, something that arrives slowly from above, drifting downward through the darkness. A steady, almost invisible connection between the surface world and the deepest trenches. This connection feeds not just amphipods, but nearly all life in the deep. It is gentle, constant, and easy to overlook. And it falls endlessly, grain by grain, from the bright world far above into the quiet depths below. Far above the deepest trenches, in waters warmed by sunlight and stirred by wind, life is busy and abundant. Plankton bloom and fade, fish feed and migrate. Countless organisms live out brief, energetic lives near the surface. And when those lives end, or when waste is released, shells are shed, or cells simply break apart, something begins a slow, quiet journey downward. This journey never stops. It is not dramatic. There are no visible streams or falling curtains. Instead, it is a gentle, continuous descent of particles, so small they are almost invisible. Bits of organic matter, fragments of once living bodies, microscopic remains, drifting steadily through kilometers of water. This is the rain from above. Sometimes it is called marine snow, but here, in the deepest ocean, it feels less like snow and more like memory. Each particle carries energy captured long ago by sunlight. Each one is a trace of life from a world that exists far beyond reach or sight. Together, they form a tenuous bridge between brightness and darkness. The descent is slow, so slow that a single particle may take weeks, months, or even years to reach the bottom. Along the way, much of it is consumed. Bacteria feed on it. Small creatures intercept it. What remains becomes thinner, poorer, more diluted. By the time it reaches the Hadal zone, it is only a faint echo of its original richness. And yet, it is enough. In a world where nothing grows quickly and nothing arrives often, even this faint echo matters. Life in the deep has adapted not to abundance, but to reliability. The rain never stops entirely. It may thin, it may slow, but it is always there, drifting downward, feeding ecosystems that exist far below the sun. The seafloor receives this rain quietly. Particles settle gently into sediment, accumulating over centuries. Layers build, each one recording a history of what lived above. In this way, the deep ocean floor becomes an archive, not of events, but of existence itself. For the creatures that live here, this rain defines opportunity. Some feed directly on particles as they fall, intercepting them before they settle. Others wait until enough material accumulates to make feeding worthwhile. Still others rely on scavengers to process the rain first, breaking it down into more accessible forms. Nothing is wasted. Every particle is part of a chain. When a larger piece arrives, a dead fish, a fragment of jelly, a rare sinking carcass, it becomes an event. Life responds. Amphipods gather. Microbes bloom. Energy moves quickly, briefly, through the system before settling once again into stillness. These moments of abundance are rare, but they sustain life for long stretches afterward. The rain from above also shapes behavior. Because food arrives unpredictably, creatures must be ready without being restless. They remain alert to chemical signals carried faintly through the water. They conserve energy, knowing that waiting is not inactivity, but preparation. This relationship with time is one of the most striking features of deep-sea life. At the surface, delay often means loss. In the abyss, patience is survival. The rain will come, not today, perhaps not tomorrow, but eventually. And life is built to last until it does. There is something quietly humbling about this connection between worlds. Surface life, busy and unaware, supports deep life simply by existing. Every breath, every bloom, every death contributes. The abyss does not demand attention or recognition. It accepts what falls. This acceptance does not mean dependence in a fragile sense. Deep-sea ecosystems are resilient precisely because they expect scarcity. They do not rely on constant input. They rely on continuity. As long as something, anything, continues to fall, life can persist. Over long spans of time, this rain has shaped evolution itself. Species that waste energy vanish. Species that wait endure. Traits that favor efficiency, storage and restraint are passed on. The rain selects not for speed, but for patience. It also creates a sense of unity across the ocean. The deepest trenches are not isolated systems. They are connected, invisibly, to everything above them. The actions of surface ecosystems ripple downward, not as waves, but as nourishment. This connection can feel comforting or unsettling, depending on how one looks at it. Comforting, because it reveals Earth as a single integrated system, where no place is truly separate. Unsettling, because it means that what happens above eventually reaches even the deepest places. For now, though, the rain continues as it always has. Quiet, persistent, indifferent. It does not rush. It does not pause. It falls, whether anyone notices or not. As we linger with this idea, it becomes clear that the rain from above is not the beginning of the deep-sea food web, but a contribution to it. Before larger creatures feed, before scavengers gather, before anything moves across the seafloor, something else is already at work. Beneath the sediment, within the particles themselves, life smaller than sight begins the process of turning falling matter into something usable. These unseen organisms form the true foundation of the deepest ecosystems, quietly transforming remnants into renewal, one molecule at a time. And it is there, in that invisible world beneath the rain, that the deepest roots of life in the abyss are found. Before any creature moves across the seafloor, before scavengers gather or fish hover in the darkness, life has already begun its work. It happens quietly, invisibly, at a scale too small to notice without careful attention. In the deepest abyss, microbes form the foundation upon which everything else depends. These microscopic organisms live within the sediment, on particles drifting down from above, and in thin films coating rocks and debris. They are not dramatic. They do not announce themselves. And yet, without them, the deep ocean would fall silent. Microbes are the first to meet the rain from above. As organic particles settle, bacteria and other microorganisms begin to break them down, slowly extracting energy and nutrients. This process does not happen quickly. It unfolds over long periods, with chemical reactions proceeding at a pace set by cold and pressure. But time is abundant here. Through this patient work, microbes transform complex organic matter into simpler compounds that other organisms can use. They recycle nutrients, release energy, and maintain the slow circulation of life at the bottom of the world. Every larger creature in the abyss relies on this invisible labor, directly or indirectly. Some microbes live entirely within the sediment, buried beneath layers of fallen material. Others cling to particles as they descend, feeding even before reaching the seafloor. Still others form communities around specific chemical conditions, thriving where certain compounds are more abundant. What's remarkable is how adaptable these microorganisms are. They tolerate pressures that would disrupt most biological processes. They function in darkness without issue. Their metabolisms are tuned to scarcity, extracting value from substances that seem almost inert. In many ways, microbes embody the essence of deep-sea life. They are efficient, persistent, and unhurried. They waste nothing. They exist wherever chemistry allows, filling every available niche. Some of these microbes have been living in the abyss for immense spans of time, evolving slowly in an environment that rarely changes. Their genetic adaptations reflect this stability. Enzymes optimized for cold, pressure-stable proteins, membranes that remain functional under crushing weight. They are specialists, but also survivors. There is something quietly awe-inspiring about imagining these microbial communities working continuously, unseen, sustaining ecosystems that span kilometers of depth. They do not require attention. They do not depend on abundance. They simply persist. Microbes also create the conditions for more complex life to exist. By processing organic matter, they enrich sediments and water with nutrients. By altering chemical gradients, they create microhabitats that other organisms can exploit. Life builds upon life, starting from the smallest scale. In some regions of the deep, microbes are not just recyclers, they are producers. In places where chemical compounds seep from the Earth's crust, certain bacteria use these chemicals as energy sources, building organic matter without any reliance on sunlight. This process feels almost alchemical, turning what seems hostile into nourishment. Even in the absence of such dramatic chemical inputs, microbes find ways to sustain themselves. They adapt to whatever energy sources are available, no matter how faint. Their flexibility sets the tone for the entire ecosystem. It is easy to overlook this invisible foundation because it does not move or shine, but it is constant. While larger creatures come and go, while scavengers gather and disperse, microbial life remains, quietly maintaining balance. This persistence gives the abyss a sense of continuity. Even when nothing appears to be happening, life is active at the microscopic level. Reactions proceed, nutrients cycle, energy flows. The deep is never truly still. There is also a sense of humility in recognizing this, that the most enduring life at the bottom of the world is not the largest or most complex, but the smallest and simplest. That survival, at its core, often belongs to those who require the least. As we linger on this thought, the abyss begins to feel less empty and more full of processes unfolding beyond our senses. The darkness hides not absence, but subtle activity, and from this foundation, life builds upward. Microbial processes support small invertebrates. Invertebrates support fish and scavengers. Each layer depends on the one below, forming a delicate but resilient network. This network operates without sunlight, without warmth, without abundance. It operates on chemistry, patience, and time. It shows that life does not need brightness to flourish. It needs opportunity and stability. The presence of microbial life also raises a gentle, expansive question. If life can sustain itself here, using energy sources so faint and slow, then what truly defines the limits of habitability? How narrow are the conditions we assume life requires? The abyss, offers its answer not in words, but in quiet persistence. Life finds a way, not by forcing itself into hostile conditions, but by discovering pathways we never thought to look for. And as this understanding settles, the focus begins to shift again, from the foundation of microbial life to the broader picture of survival without light, to the ways entire ecosystems function in perpetual darkness, sustained by chemistry and connection rather than the sun. The deep ocean invites us to imagine a world where life thrives without ever seeing the sky, a world where light is unnecessary and existence unfolds in complete and lasting night. In the deep ocean, the idea of day and night has no meaning. There is no sunrise to begin activity, no sunset to signal rest. Darkness is not an event here. It is the constant state of things, and within that constant, life unfolds without ever knowing the warmth or guidance of the sun. It can be difficult to imagine a living world without light, because light defines so much of our own experience. It shapes how we see, how we move, how we grow food, how we measure time. We often think of sunlight as the beginning of life's story, the spark that makes everything else possible. And in many places, that is true, but the abyss gently loosens that assumption. Here, life does not wait for light. It does not miss it. It has never known it. Instead, it builds its existence on other forms of energy, subtle, steady, and often invisible. The sun may be absent, but the flow of energy continues, redirected through chemistry, pressure, and time. In this world, photosynthesis is impossible. No green plants grow, no algae drift, no reefs rise toward brightness. And yet, ecosystems persist, sustained by pathways that feel almost counterintuitive at first. Energy arrives slowly, carried by falling particles, processed by microbes, recycled endlessly. But beyond this rain from above, there are other sources too, sources that originate not in the sky, but in the earth itself. Within the planet's crust, chemical reactions release energy. Certain compounds seep upward through fractures in the seafloor. In places where these chemicals meet seawater, life finds opportunity. Microorganisms learn to tap into these reactions, drawing energy directly from chemistry rather than light. This way of living feels almost ancient, as if it reaches back to a time before the sun dominated life's rhythms. It suggests that light was not life's first teacher, but merely one of many. In a sunless world, growth looks different. Without light-driven abundance, ecosystems become sparse, population densities are low, encounters between organisms are infrequent. But this sparsity does not imply weakness, it implies balance. Life without sunlight learns to exist within limits. It does not expand rapidly or consume recklessly. It grows slowly, guided by availability rather than ambition. In this way, darkness becomes a stabilizing force. There is no competition for light here, no shadows to outgrow. Instead, life competes gently for energy, sharing space through time rather than conflict. Each organism occupies its niche quietly, contributing to a network that persists precisely because it does not strain itself. This network feels calm. Creatures move less, they rest more, they spend long periods conserving energy, waiting for opportunity. When action happens, it is purposeful. Nothing is done without reason. The absence of light removes distraction. There is only necessity. Sensing, too, takes on new meaning. Without vision as a primary guide, organisms rely on other ways of knowing. Chemical gradients become maps. Pressure changes become signals. Vibrations carry information across distances. The world is not empty of cues. It is simply tuned differently. This tuning shapes behavior. Instead of reacting to what they see, deep-sea creatures respond to what they feel and detect chemically. Awareness becomes diffuse, spread throughout the body rather than focused in the eyes. The environment is known not as an image, but as a field of subtle changes. There is something quietly profound about this mode of existence. It suggests that perception itself is adaptable, that awareness does not depend on light any more than life does. Knowing the world is not limited to seeing it. Life without sunlight also redefines beauty. There are no colors in the usual sense, no landscapes illuminated by brightness. Beauty here lies in function, in balance, in the quiet effectiveness of systems that work without spectacle. It is a beauty felt rather than seen. As we linger with this thought, the abyss begins to feel less like an absence of light and more like a different kind of presence. Darkness is not a void. It is a canvas on which other forms of life paint their existence. This realization can feel comforting. It suggests that life does not need ideal conditions. It needs workable ones. And when those conditions are stable, even if they seem harsh to us, life can flourish in its own way. The deep ocean shows us a version of existence stripped of excess. No abundance of energy, no rapid growth, no constant change, just continuity, just persistence. And within that persistence lies a powerful lesson that life is not fragile because it is adaptable. It is not limited because it is creative. It does not depend on any single source of energy or comfort. It explores every pathway that chemistry and time allow. As we rest in this understanding, another curiosity naturally arises. If life can thrive without sunlight, what exactly fuels it at the most fundamental level? What process replaces photosynthesis, building ecosystems from chemical reactions alone? The answer flows quietly through the deep, shaping entire communities in darkness. It is a process that feels almost alien at first, yet deeply logical once understood. A way of living that turns chemistry itself into nourishment, creating life where light never reaches. In the absence of sunlight, life does not stop asking for energy. It simply learns to listen elsewhere. In the deep ocean, that listening takes the form of chemistry. Quiet reactions unfolding in darkness, releasing just enough energy to sustain a living world. Chemosynthesis is the name given to this way of life, though the word itself feels heavier than the process it describes. At its heart, it is simple. Instead of capturing energy from light, certain organisms capture energy from chemical reactions. Where light once powered growth, chemistry now does. Deep beneath the surface, the earth is not inert. Heat moves through rock, minerals dissolve, gases seep slowly upward through cracks in the crust. When these substances meet seawater, reactions occur. Some release energy, not explosively, but steadily. Like a slow-burning ember, microorganisms have learned to use that energy. They take chemicals that would be useless or even deadly to surface life and turn them into fuel. Hydrogen sulfide, methane ion compounds, substances that smell of decay or seem hostile become nourishment here. Through carefully tuned biochemical pathways, microbes harvest the energy released when these chemicals change form. This process builds organic matter from scratch, without sunlight, without plants, without leaves or chlorophyll. Carbon is fixed into living tissue, cells grow, communities form, an ecosystem begins, anchored not to the sky, but to the earth itself. It can feel almost magical to imagine life growing out of stone and water alone, but it is not magic. It is chemistry given time. Chemosynthetic microbes often live clustered around places where chemical energy is more concentrated. Subtle seeps, mineral-rich sediments, slow leaks from the seafloor. These are not dramatic fountains or glowing vents. Many are gentle, barely noticeable gradients. And yet, they are enough. Around these microbial foundations, other life gathers. Small invertebrates feed on the microbes directly. Larger organisms feed on those invertebrates. A food web forms, step by step, sustained by reactions happening far below the reach of sunlight. What's striking is how independent this system is from the surface world. While marine snow continues to fall, chemosynthesis does not rely on it. Even if the rain from above were to thin, chemical energy would remain. Life here is anchored to the planet's inner workings rather than its outer cycles. This independence reshapes how we think about ecosystems. It shows that life does not need to be tethered to the sun to be complex or enduring. It can root itself in geology, drawing energy from the slow movements of the earth itself. There is something deeply ancient about this. Long before plants spread across land, before the atmosphere filled with oxygen, chemical energy likely powered some of the earliest life on Earth. In the deep ocean, that ancient pathway continues, largely unchanged, quietly sustaining life as it always has. Chemosynthesis also carries a sense of patience. The reactions it depends on are slow. Energy is released gradually. Growth is measured. Nothing rushes. This pace suits the deep perfectly, aligning with its stable temperatures and constant pressure. Life built on chemosynthesis does not surge or collapse. It persists. For organisms living in this world, chemical cues replace visual ones. They sense gradients of concentration, moving toward areas where energy is more available. The environment becomes a map drawn in chemistry rather than light, and life learns to read it with precision. This chemical awareness shapes behavior in subtle ways. Movements are guided by invisible trails. Positioning matters. Small shifts can mean the difference between nourishment and scarcity. Attention is focused inward, on the body's interaction with its immediate surroundings. As this understanding settles, chemosynthesis begins to feel less alien and more intuitive. It is simply another way of accessing energy, another solution discovered by life in response to available conditions. And perhaps that is the most calming realization of all. Life does not insist on one method. It does not cling to a single strategy. It explores, it adapts, it listens to what the environment offers and responds accordingly. In the deep ocean, the environment offers chemistry, and life accepts. This acceptance creates ecosystems that feel both fragile and enduring. Fragile because they depend on subtle gradients, enduring because those gradients change slowly, often over geological timescales. The result is a quiet stability that mirrors the stillness of the abyss itself. As we drift with this idea, it becomes clear that chemosynthesis is not just a survival strategy. It is a reminder of life's creativity, a demonstration that existence can be built on pathways we rarely notice, powered by reactions happening beyond our senses. The abyss, once imagined as empty, reveals itself as a place where life writes its story in molecules rather than light, where nourishment flows from stone and water, where ecosystems thrive without ever seeing the sun. And with this understanding comes another gentle curiosity. If life can turn such harsh chemicals into sustenance, what does that mean for substances we consider toxic or deadly? How does survival reshape what nourishment even is? In the deep, the line between poison and food blurs, and life learns to dine on what the surface world would never touch. In the deep ocean, the idea of poison loses its certainty. Substances that would burn lungs, corrode tissues, or suffocate surface life become, in the abyss, sources of nourishment. What feels deadly above becomes ordinary below, not because the chemicals are gentler, but because life has learned how to meet them differently. Here, survival is not about avoiding danger, it is about understanding it. Hydrogen sulfide, for example, carries the unmistakable smell of decay to human senses. Even in small amounts, it can be lethal to us, and yet, in the deep, entire communities rely on it. Microbes have evolved pathways that capture the energy released when this compound is transformed, turning something toxic into fuel. What would poison one form of life sustains another. This transformation is not dramatic. It happens quietly, molecule by molecule, through reactions that unfold with calm precision. The chemicals themselves do not change their nature. Life changes its relationship to them. The same is true for methane, iron-rich compounds, and other substances seeping slowly from the Earth's crust. In the surface world, these chemicals are often treated as hazards. In the abyss, they are invitations. Where they appear, life gathers, not in abundance, but in alignment. Organisms living in these conditions are not immune to toxicity in a simple sense. They are compatible with it. Their biochemistry is tuned to handle compounds that would disrupt ordinary cellular processes. Enzymes are structured to guide reactions safely. Membranes are adapted to prevent damage. The chemistry of life reshapes itself around what the environment provides. This reshaping reveals something subtle and profound. Toxic is not an absolute category. It is contextual. A substance becomes toxic only when an organism lacks the tools to process it. Give life time, and those tools can emerge. In the deep ocean, time is generous. Chemical diets also change how energy is valued. The reactions that sustain life here release less energy than sunlight-driven photosynthesis. There is no surplus. Nothing is wasted. Every reaction is measured, every pathway optimized. Growth is slow because energy arrives slowly, but it arrives consistently. This consistency matters more than abundance. It allows life to settle into predictable rhythms, even in an environment that feels extreme. Stability replaces comfort as the key to survival. There is something quietly reassuring about this, that life does not need ideal conditions, only workable ones. That what appears hostile from one perspective can be life-giving from another. Chemical survival also fosters close partnerships. In many deep-sea ecosystems, microbes live in intimate association with larger organisms. Some animals host bacteria within their tissues, providing them with access to chemicals while receiving nourishment in return. These relationships are not temporary. They are ancient, refined by countless generations. Such partnerships blur the line between individual and environment. The organism becomes a living habitat. Survival becomes collaborative rather than solitary. In the darkness, where resources are sparse and conditions unchanging, cooperation offers efficiency. Sharing chemical processing reduces risk. It distributes effort. It allows life to persist where isolation might fail. This cooperative survival stands in contrast to surface world narratives that emphasize competition. In the abyss, competition exists, but it is subdued. There is little advantage in aggression when energy is scarce. Instead, life leans toward balance, toward arrangements that conserve rather than consume. As we linger on this idea, the abyss begins to feel less alien. Its rules are different, but they are not harsh. They are precise. Life does not struggle here, it aligns. Chemical diets also carry a sense of humility. They remind us that life's ingenuity does not always announce itself through complexity or speed. Sometimes it reveals itself through quiet adjustments that make the impossible feel ordinary. It is tempting to think of these adaptations as extreme, but for the organisms living here, they are simply normal. There is no awareness of danger, no sense of overcoming adversity. There is only existence, shaped by conditions that have always been present. This normalcy is important. It reframes survival not as a battle, but as a relationship. Life does not conquer the deep ocean's chemistry. It learns to live within it. As this understanding settles, the idea of toxic becomes softer, less absolute. It becomes a reminder that our definitions are shaped by our own limits, not by life's full range of possibility. The deep ocean does not ask life to be comfortable. It asks it to be compatible. And compatibility brings its own kind of peace. In this chemical world, energy moves slowly. Reactions take time. Processes unfold at a pace that feels almost meditative. This slowness seeps into every aspect of existence, shaping how organisms grow, move, and reproduce. Life here is not rushed. It cannot afford to be, As we drift gently with this thought, attention turns to the rhythm that defines the abyss more than any other, the slow pulse of metabolism. In a world where energy is precious and time is abundant, life learns to stretch itself across years, even decades, surviving not by speed, but by patience. The deep teaches this lesson quietly, through bodies that move slowly, hearts that beat gently, and lives that unfold in extended calm. In the deep ocean, life does not hurry. There is no advantage in haste when energy arrives sparingly and unpredictably. Instead, survival unfolds through restraint, through bodies and processes tuned to last rather than to rush. Here, metabolism itself becomes an exercise in patience. Metabolism is the quiet engine of life. It governs how energy is used, how cells repair themselves, how growth proceeds. At the surface, metabolism often runs fast. Warm temperatures accelerate chemical reactions. Abundant food encourages frequent feeding and rapid development. Speed in many cases is rewarded. In the abyss, the opposite is true. Cold water slows reactions. Pressure alters chemistry. Scarcity limits intake. Together, these forces encourage a slower pace of life, one where energy is spent carefully and replenished infrequently. Metabolic rates drop, not as a sign of weakness, but as a strategy. This slowness brings unexpected benefits. With lower metabolic demands, organisms can survive on minimal input. A single feeding event may sustain them for weeks or months. Fat reserves are used sparingly. Muscles rest more than they work. Movement becomes occasional rather than constant. There is a quiet wisdom in this economy. Long survival becomes possible because wear and tear is reduced. Cells divide less often, accumulating fewer errors. Tissues repair slowly but steadily. In a stable environment with little change, there is no pressure to grow quickly or age fast. Time stretches. Many deep-sea organisms are thought to live far longer than their surface relatives. Some fish, invertebrates, and microbes may persist for decades, even centuries, their lives unfolding in a calm continuity that feels almost timeless. Age here is not marked by seasons or milestones, but by gradual change. This longevity is not dramatic. It is not accompanied by size or dominance. It is simply endurance, a capacity to remain, to persist, to continue being alive without interruption. Slow metabolism also shapes behavior. Animals rest for long periods, conserving energy. When they move, it is deliberate. When they feed, it is thorough. There is little room for waste. Every action is weighed, not consciously, but biologically. The deep ocean encourages a kind of biological mindfulness. Nothing is done without reason. Nothing is rushed. Life settles into a rhythm that mirrors the environment, steady, predictable, unchanging. This rhythm feels calming to imagine. In a world so often defined by urgency, the abyss offers a counterpoint. It shows that life does not need constant stimulation to persist. It can thrive in quiet, in repetition, in slow cycles that repeat over generations. Slow metabolism also reduces risk. With fewer movements, organisms draw less attention. With lower energy needs, they are less vulnerable to gaps in supply. With stable chemistry, they are less affected by minor fluctuations. The deep rewards caution. As we linger with this idea, the abyss begins to feel less harsh. Its conditions are demanding, yes, but they are consistent. And consistency allows life to plan, not consciously, but through evolution. Traits that favor patience accumulate. Strategies that emphasize endurance prevail. This is survival not as struggle, but as alignment. Even reproduction follows this rhythm. Growth is slow. Maturity takes time. Offspring may be few, but they are well adapted to the environment they will inherit. There is no pressure to produce rapidly when conditions remain stable across long spans of time. The deep ocean is not a place of boom and bust. It is a place of continuation. There is something deeply grounding about that. It suggests that life's success does not always depend on expansion or conquest. Sometimes, success means remaining present, maintaining balance, and using just enough energy to persist. This perspective reshapes how we think about resilience. Resilience is not always loud or forceful. It can be quiet, steady, almost invisible. It can look like waiting, like resting, like conserving. In the abyss, life has perfected the art of waiting. As we drift with this understanding, another gentle question forms. In such a slow, sparse world, how does life continue itself? How do organisms find one another, reproduce, and ensure that existence carries on when encounters are rare and distances are vast? The answer is as patient and inventive as everything else in the deep unfolding, through strategies shaped not by abundance, but by isolation, stillness, and time itself. In a world where encounters are rare and movement is measured, the continuation of life requires quiet ingenuity. The deep ocean does not offer crowded gatherings or predictable meeting places. Distances are vast, populations are sparse, and yet life persists, generation after generation, finding ways to reach forward in time even when reaching one another is difficult. Reproduction in the abyss is shaped by patience. Many deep-sea organisms do not rely on frequent contact. Instead, they adopt strategies that make use of chance, timing, and endurance. Some release reproductive cells into the water, trusting currents, slow and subtle though they are, to carry them where they need to go. Success may be rare, but time is generous, and repetition makes possibility. Others take a more intimate approach. When encounters do happen, they matter. Some species are able to store genetic material for long periods, holding on to it until conditions are right. In this way, a single meeting can support multiple reproductive cycles, reducing the need for frequent contact. This ability to wait is essential. In the deep, opportunity does not arrive on schedule. It arrives when it arrives. Life learns to be ready without being rushed. Some organisms blur the line between individual and lineage. Certain deep-sea creatures can reproduce without a partner, creating offspring that are genetic continuations of themselves. This strategy reduces dependence on chance encounters entirely. It is not the most diverse path forward, but in a stable environment, diversity is less urgent than continuity. There is something quietly elegant about this. In the abyss, reproduction is not about abundance or competition. It is about persistence, about ensuring that life continues even when conditions are limiting. Energy constraints shape these strategies as well. Producing offspring is costly, and in a world where energy is scarce, excess is avoided. Many deep-sea species produce fewer offspring, investing more in each one. Development may be slow, but it is thorough. Offspring emerge already suited to their environment, prepared for the stillness and pressure they will inherit. This investment reflects a long-term view of survival. There is no rush to populate. There is only the need to remain. The absence of light also changes how reproductive signals are sent and received. Without visual cues, organisms rely on chemical signals, subtle changes in the water that carry information about readiness and presence. These signals diffuse slowly, but they persist, creating a quiet conversation that unfolds over time. In this way, the deep ocean becomes a place where communication is gentle and indirect. Messages are not shouted. They are released and allowed to drift, trusting that they will be sensed by those attuned to them. Some species synchronize reproduction with environmental cues that remain constant even in darkness. Pressure changes, chemical availability, or the arrival of food from above. These cues act as markers, aligning reproductive timing across individuals who may never meet. This synchronization creates a sense of collective rhythm, without proximity. Life moves together without gathering, connected by shared conditions rather than shared space. There is also a softness to reproduction here. No frantic courtship, no dramatic displays, just alignment, readiness, and continuation. The abyss does not reward spectacle, it rewards fit. As we linger on this thought, reproduction in the deep begins to feel less mysterious and more intuitive. It is shaped by the same principles that govern everything else here: efficiency, patience, and balance. Life does not need constant renewal to survive. It needs steady renewal. This steadiness allows lineages to persist across immense spans of time. While surface environments change rapidly, deep-sea conditions remain remarkably stable. Species evolve slowly, carrying forward adaptations that have proven effective over millions of years. Reproduction becomes a bridge across geological time, linking past and present in a continuous thread. There is something quietly comforting in this continuity, that even in the most isolated places on Earth, life finds ways to continue without urgency or excess. That existence does not depend on constant interaction, but on alignment with enduring conditions. As this understanding settles, attention shifts again, not to how life continues through time, but to how it experiences the world moment by moment. In darkness, where sight offers little guidance, perception must take other forms. How does life know where it is? How does it navigate, find food, sense danger, or recognize opportunity without ever seeing its surroundings? The answers lie not in eyes, but in senses tuned to a world defined by pressure, vibration, and chemistry, a world where knowing is felt rather than seen. In the deep ocean, sight is no longer the primary way of knowing the world. Darkness is complete and unchanging, and eyes, where they exist at all, are limited in what they can offer. Yet life here is not unaware. It is not blind in the way we might imagine. Instead, it perceives through other means, sensing its surroundings with a quiet precision that feels almost intuitive. Without light, the ocean becomes a place of subtle signals. Water carries information constantly, through pressure, vibration, chemistry, and movement. Deep-sea life learns to read these signals the way we read faces or landscapes, building a picture of the world without ever seeing it. Pressure is one of the most reliable guides. Even slight changes in water movement create pressure gradients that ripple through the body. Sensitive cells detect these shifts, allowing organisms to sense nearby motion, a distant scavenger stirring sediment, a larger animal passing slowly overhead, the approach of a current carrying new chemical information. All of this is felt long before it could ever be seen. Vibration, too, becomes a form of language. Sound travels far and efficiently through water, especially in the deep, where there is little interference. Movements send low-frequency vibrations that spread outward, informing others of presence, size, and direction. Life listens with its whole body, not just with ears. Chemical sensing may be the most important of all. Molecules drifting through the water carry messages about food, reproduction, and danger. A faint trace of organic matter signals nourishment. A change in composition hints at geological activity. Reproductive cues spread slowly, persisting long enough to be found even across distance. These chemical trails do not point like arrows. They form gradients, gentle slopes of concentration that organisms learn to follow. Navigation becomes an exercise in reading subtle differences, moving toward what feels right rather than what looks obvious. This way of sensing encourages patience. Chemical information takes time to spread. Pressure changes unfold gradually. Life learns to wait, to sample its environment continuously, adjusting course in small increments rather than making sudden decisions. There is something deeply calming about this sensory world. It is not overloaded. There are no flashing lights, no constant noise. Information arrives softly, layered and continuous. Awareness is spread throughout the body rather than focused in one organ. Some deep-sea creatures still possess eyes, but these eyes are different. They may be oversized, tuned to detect the faintest glimmer of light, or they may be reduced, serving secondary roles rather than forming images. Vision becomes just one sense among many, not the dominant one. For others, eyes disappear entirely. In their place, sensory cells spread across skin and appendages, detecting contact and movement directly. The world is known through touch and flow, through the way water presses and shifts around the body. This distributed awareness creates a kind of embodied perception. The organism does not observe the environment from a distance. It exists within it, feeling changes as they happen. The boundary between self and surroundings becomes softer, more permeable. Such perception suits the deep perfectly. With little change and few sudden events, awareness does not need to be sharp or fast. It needs to be steady and reliable. Deep-sea life senses the world as a field of conditions, rather than a series of objects. This field-based awareness also supports survival in sparse environments. When food is rare, detecting faint signals matters. When encounters are infrequent, recognizing subtle cues becomes essential. The abyss rewards sensitivity over speed. As we rest with this idea, the deep ocean feels less empty. It feels attentive, alive with quiet sensing, with organisms continuously reading and responding to their surroundings in ways that feel almost meditative. There is a lesson here, gently offered, that knowing does not require seeing, that awareness can be broad, patient, and calm, that attention can exist without urgency. In the abyss, life demonstrates this effortlessly, and yet occasionally, darkness is broken not by sunlight, but by something else. Brief flashes, soft glows, subtle points of light that appear and fade, used sparingly and purposefully. Light, when it appears here, carries meaning. It is not abundant, it is not constant, but it is there, waiting quietly at the edge of perception, ready to be used when the moment calls for it. In a world defined by darkness, light becomes something precious. It is not scattered freely or wasted casually. When it appears in the deep ocean, it does so with intention, brief, controlled, and meaningful. Bioluminescence is not illumination here. It is language. This light does not come from the sun or from fire. It is created within living bodies through quiet chemical reactions, where stored energy is released as a soft glow. The colors are often gentle, blues and greens that travel farthest through water, appearing and vanishing without sound. In the abyss, light is not a constant presence. It is an event. For some organisms, bioluminescence is a way to communicate in a place where vision is otherwise limited. A brief pulse can signal readiness, recognition, or warning. These signals are subtle, designed to be noticed by those attuned to them and ignored by everything else. Nothing here shines without reason. Others use light to confuse or deter. A sudden flash can disrupt a predator's sense of direction, buying time to drift away. In an environment where movement is slow and encounters are rare, even a moment of confusion can be enough. Light becomes a shield made of surprise. There are creatures that use bioluminescence as bait, releasing a faint glow to draw curious organisms closer. In the darkness, light is irresistible, promises information, opportunity, perhaps even safety. But in the deep, curiosity must be careful. Light can invite as easily as it can warn. What's striking is how restrained these displays are. There are no constant glows lighting the seafloor, no shimmering horizons. Light appears only when needed, then disappears again, leaving darkness undisturbed. Energy is conserved, attention is controlled. This restraint reflects the deep ocean's broader philosophy of survival. Nothing is done without purpose, nothing is wasted. Even beauty is efficient. Bioluminescence also reshapes the idea of color. Without ambient light, color has no meaning until it is created. When an organism glows, it defines its own palette, choosing wavelengths that travel far and are easiest to detect. Blue dominates not because it is beautiful, but because it works. And yet, there is beauty in that practicality. A soft blue pulse in total darkness carries a quiet elegance. It is not meant to be admired, it is meant to be understood. For organisms with eyes tuned to these faint glimmers, bioluminescence becomes a way to read the environment. Distant flash may indicate movement. A steady glow may mark a living structure. Light becomes information rather than scenery. Some species use bioluminescence to blend in rather than stand out. By matching the faint glow filtering down from above, light scattered from distant surface reflections, they erase their silhouettes, becoming nearly invisible when viewed from below. In this way, light is used not to reveal, but to conceal. This strategy, called counter-illumination, shows just how nuanced life's relationship with light can be. Even in darkness, the absence of light is not absolute. There are gradients, faint traces, subtle differences. Life learns to navigate these subtleties with precision. It's easy to imagine bioluminescence as dramatic, like fireworks in the deep. But in reality, it is more like a whisper, brief, controlled, almost private. Many displays are so faint they would go unnoticed unless one were watching carefully, patiently. This patience is essential. The deep does not reveal itself to those who rush. It offers glimpses to those who linger. As we linger here in thought, the occasional appearance of light feels like reassurance rather than spectacle. It suggests presence without noise, communication without intrusion. It reminds us that even in the darkest places, life finds ways to express itself, gently, sparingly, and with intention. There is also something comforting about the fact that light here is not imposed from above. It is created from within. Organisms do not wait for illumination. They generate it when needed, on their own terms. Darkness does not define them. They define how and when it is broken. This autonomy carries a quiet strength. It shows that even in environments that seem limiting, life can create its own tools, its own signals, its own moments of clarity. And yet, bioluminescence remains rare. Most of the deep ocean passes its time in complete darkness, uninterrupted. Life here does not depend on light. It uses it only when it adds value. As this understanding settles, darkness regains its calm dominance. The abyss returns to stillness, illuminated only by the occasional, purposeful glow. This stillness leaves space for mystery, because even with cameras and lights, even with brief flashes of bioluminescence, most of the deep remains unseen. Vast areas have never been observed. Countless organisms have never been documented. The abyss holds life that may never know observation, never encounter light from our machines, never be named or categorized. And in that unseen existence lies one of the deep ocean's most profound truths: that life does not need to be witnessed to be real, and that much of Earth's living story unfolds quietly, beyond our awareness, in darkness that remains intact. There is a quiet acceptance that comes with realizing how little of the deep ocean has truly been observed. Even with advanced instruments, even with patient cameras and careful descents, our glimpses are brief and narrow. We look through small windows into a vast dark expanse, and most of it remains untouched by light or attention. In the deepest regions, life may exist that has never encountered anything other than darkness, pressure, and time. Entire species may live and die without ever crossing paths with our machines. They do not hide from us. They simply exist beyond the limits of our reach. This is not because they are rare, necessarily, but because the environment itself is immense and difficult to access. The Hadal zone is fragmented into trenches and folds, each with its own subtle conditions. Reaching one does not mean understanding another. Every descent is a single point in a vast three-dimensional space. Life in these places does not gather in crowds. It spreads thinly, quietly, occupying niches defined by chemistry and gravity. Many organisms are small, slow, and unobtrusive. They leave little trace. They do not announce themselves with movement or light. To notice them requires time, patience, and often a kind of luck. And so, many remain unnoticed. This does not diminish their importance. In fact, it deepens it. The deep ocean reminds us that existence does not require recognition. Life does not need to be catalogued to be meaningful. It does not need to be seen to matter. There is something gently humbling about this idea. So much of Earth's living complexity unfolds beyond human awareness, following rhythms and rules that do not include us. The planet is not arranged around observation. It is arranged around continuity. Unseen life may play roles we do not yet understand. Microbial communities shaping chemical cycles, small invertebrates redistributing nutrients, subtle interactions maintaining balance in ecosystems that stretch across kilometers of depth. These processes do not pause because we are unaware of them. They continue, quietly supporting the larger system. The possibility of unseen life also invites patience in our understanding. It reminds us that knowledge grows slowly, especially in environments as challenging as the deep sea. Every discovery is provisional, a small addition to a picture that remains incomplete. There is comfort in this incompleteness. It suggests that mystery is not a failure of understanding, but a natural state, that the world is allowed to remain larger than our explanations. In the abyss, mystery feels calm rather than unsettling. It does not threaten, it simply exists, like the darkness itself, vast, steady, and unchanging. Knowing that life thrives there without ever being observed adds to that calm. It shows that existence is not dependent on attention. For the organisms living unseen, nothing is missing. Their lives are complete. They sense their environment. They feed, grow, reproduce, and die. The absence of observation does not diminish these processes. If anything, it preserves them from disruption. This perspective softens our relationship with exploration. It shifts the focus from conquest to curiosity, from possession to respect. The deep ocean is not a puzzle to be solved completely. It is a presence to be approached thoughtfully. As we consider unseen life, the abyss begins to feel less distant. It mirrors something familiar, the countless moments in our own lives that pass without record or witness, yet still matter. The quiet routines, the unnoticed growth, the slow changes that shape who we are. Life does not need an audience to be real. The deep ocean holds this truth gently. It offers it without urgency, without insistence. It simply demonstrates it, again and again, through organisms that persist beyond our awareness. And yet, even unseen, these lives are not isolated from us. The ocean is a connected system. What happens at the surface eventually reaches the depths, carried by currents, particles, and chemistry. The unseen is still affected by the seen. This connection brings with it a subtle responsibility, because even the deepest places, once thought untouched, have begun to show traces of the surface world. Small fragments, unexpected residues, evidence that human presence extends farther than we ever intended. The realization arrives quietly, like everything else in the abyss. It does not announce itself loudly, but it lingers, inviting reflection. If life exists here without ever being seen, then what does it mean when our influence reaches it anyway? What does it mean when the most remote ecosystems on Earth carry signatures of activity from far above? The abyss, patient and enduring, begins to reflect our own world back to us, not in judgment, but in connection. It shows us that nothing is truly isolated, that even the deepest darkness is part of the same system we inhabit. And as this thought settles, attention turns gently toward that influence, toward the subtle, unexpected ways human activity has begun to appear at the bottom of the world, carried there not by intention, but by gravity and time. The unseen life of the abyss continues, quietly and resiliently, even as it encounters traces of a distant surface world it will never see. For most of human history, the deepest parts of the ocean felt safely beyond our reach, too far down, too heavy, too dark to be touched by anything we did above. It was comforting to believe that there were places on Earth untouched by our presence, places where life unfolded without ever intersecting with human activity. The abyss quietly challenges that belief. When scientists began examining organisms from the deepest trenches, they expected to find isolation preserved, life shaped only by geology, chemistry, and time. What they found instead was something far more subtle and far more unsettling. Tiny fragments of human-made material embedded where they did not belong. Microplastics, fibers, synthetic particles, small enough to drift unnoticed, yet persistent enough to travel miles downward through the water column. These fragments did not arrive suddenly. They fell slowly, like everything else, carried by the same gentle rain that feeds life in the deep. They joined the long descent from surface to seafloor. Gravity did the rest. At first, the discovery felt almost abstract. The particles were microscopic. Their quantities were small, and yet their presence was undeniable. Even at the bottom of the world, traces of human industry had arrived. What makes this realization particularly striking is not the scale of the contamination, but its reach. The Hadal zone is among the most remote environments on Earth. Few machines have visited it. No humans have lived there, and still, the imprint of the surface world is present, woven quietly into the fabric of the deep. For the organisms living there, these particles are not recognized as foreign. They are simply part of the environment, another kind of falling matter. Some are ingested accidentally, others become embedded in sediments. Over time, they enter the slow cycles of deep-sea ecosystems, interacting with life that evolved long before humans existed. This interaction is not dramatic. There are no sudden collapses or visible disruptions. The deep ocean rarely responds quickly to change. Its pace is too slow. Its process is too gradual. But that slowness also means that what enters the system tends to remain. Plastics do not decompose easily in cold, dark conditions. They persist, breaking down into ever smaller fragments without truly disappearing. Each piece becomes part of the environment, potentially interacting with microbial processes, chemical cycles, and living tissues over long spans of time. There is a quiet irony in this. The deep ocean, a place defined by patience and endurance, now hosts materials designed for convenience and disposability. Two timelines intersect, one measured in geological time, the other in moments of use. This intersection does not feel accusatory. It feels reflective. The abyss does not reject these materials, does not react with alarm. It absorbs them, as it absorbs everything that falls. The responsibility lies not with the deep, but with the realization that nothing we release truly disappears. For some organisms, ingesting microplastics may have subtle effects, interfering with digestion, altering chemical balances, introducing compounds that did not exist in their evolutionary history. These effects are difficult to measure in environments so hard to study. The deep does not offer quick feedback, and yet, the presence alone carries meaning. It tells us that distance is not protection, that remoteness does not equal isolation, that Earth's systems are more interconnected than we often allow ourselves to believe. What we do at the surface does not stay at the surface. It travels, slowly, quietly, but inevitably. There is something sobering about imagining a tiny plastic fiber settling gently into Hadal sediment coming to rest beside microorganisms that have existed for millions of years. Two vastly different histories meeting in silence. This image does not need to provoke fear to be powerful. It simply invites awareness. The deep ocean has always been a mirror of sorts, not reflecting our faces, but reflecting our assumptions. We once assumed it was lifeless. We were wrong. We assumed it was isolated. We were wrong again. Now it shows us that our influence extends farther than our intentions. And still life persists. The organisms of the abyss do not stop living because something new has arrived. They continue their slow rhythms, their quiet cycles. Microbes still break down organic matter. Scavengers still gather when food appears. Fish still hover in darkness, perfectly adapted to pressure and cold. This persistence is not indifference. It is resilience. The deep ocean does not dramatize change. It integrates it. Slowly, patiently. Over time, small influences accumulate. Whether those influences ultimately alter ecosystems in significant ways is a question that unfolds over decades and centuries rather than days. This long view is both comforting and humbling. Comforting because it shows life's capacity to endure. Humbling because it reminds us that our actions participate in systems far larger and slower than we often consider. As we rest with this understanding, the abyss feels less like a distant place and more like a shared one, not shared in presence, but in consequence. The deepest life on earth is not separate from us. It is connected, quietly and continuously. This connection does not demand guilt or urgency in this moment. It invites attentiveness. It asks for care shaped by patience, much like the deep itself. And as this thought settles, the journey nears its quiet reflection, not toward endings or conclusions, but toward a broader understanding of what the abyss truly represents, not as a place of monsters or emptiness, but as something else entirely. A place where life persists beyond expectation, where resilience outpaces imagination, where the planet keeps its deepest proofs of survival, hidden not for fear, but for wonder. When all the noise fades, when assumptions fall away, when expectations soften, when fear gives way to quiet curiosity, the deepest abyss reveals what it has been holding all along. Not monsters, not emptiness, but proof that life is not fragile in the way we once believed. Proof that survival does not depend on comfort, light, or ease. Proof that existence, given time, will explore every corner of possibility. The deepest parts of the ocean are not failures of habitability. They are confirmations of it. Here, beneath crushing pressure and endless darkness, life does not cling desperately to the edge. It settles. It adapts. It becomes so thoroughly integrated with its environment that the distinction between organism and world begins to blur. Bodies soften, chemistry adjusts, time slows, and life continues, not loudly, not visibly, but faithfully. The abyss acts like a vault, not because it locks life away, but because it preserves it. Conditions here change so slowly that ancient adaptations remain relevant for millions of years. While surface ecosystems rise and fall, warm and cool, expand and retreat, the deep endures. It remembers. In this sense, the abyss is not a frontier of exploration. It is a reservoir of resilience, a place where evolution has archived its most patient solutions, where survival is not optimized for speed or dominance, but for continuity. Nothing here rushes toward progress. Nothing needs to. Life in the deepest ocean reminds us that endurance can be quiet, that success can look like stillness, that thriving does not always resemble growth. It can resemble balance. There is something deeply calming in that realization. We often imagine resilience as strength under pressure, as resistance against force. The abyss offers a gentler definition. Resilience here is flexibility. yielding without breaking, adapting without announcing, becoming so well matched to conditions that struggle dissolves into normalcy. The creatures of the deep do not feel heroic. They feel they exist because they fit, and perhaps that is why the abyss feels less frightening the longer we sit with it. It does not threaten, it does not judge, it does not perform. It simply exists, holding life in forms that challenge our imagination, but follow a clear, internal logic. This logic extends beyond Earth. If life can persist here, without sunlight, under extreme pressure, sustained by chemistry and patience, then the universe suddenly feels more welcoming. Worlds once dismissed as barren begin to feel uncertain. Ice-covered oceans, subsurface seas, planets far from stars. The abyss does not promise life elsewhere, but it gently widens the question. It teaches us not to underestimate existence. Yet even without looking outward, Earth alone feels richer after this journey. The planet becomes deeper, not just physically, but conceptually. It holds more life in more forms than we once allowed ourselves to believe, and much of that life asks nothing of us. It does not seek discovery. It does not demand recognition. It simply continues. There is humility in that, and comfort. The abyss does not hide horrors. It hides patience. It hides systems that work quietly, efficiently, without drama. It hides proof that life is not a delicate flame easily extinguished, but a persistent current that flows wherever conditions allow. Even human influence, reaching farther than intended, does not erase this truth. It merely reminds us that we are part of the same system, participants rather than observers. What we release eventually falls. What falls eventually integrates. The deep absorbs without complaint, without spectacle. This does not make it invulnerable, it makes it honest. And honesty is what the abyss offers most clearly. It strips life down to essentials and shows us what remains when comfort, light, and abundance are removed. What remains is not fear, it is not chaos. What remains is persistence. As the thought settles, the deepest abyss no longer feels like a place beneath us. It feels like a place within the planet, quietly supporting it, stabilizing it, holding its oldest truths in darkness and pressure. Life does not end where light disappears. It simply changes its language, and somewhere far below the surface, in water that has never known the sun, that language continues to be spoken, slowly, softly, and without interruption, reminding the earth, and anyone willing to listen, that existence is far more resilient than we ever imagined.